JavaScript is the most popular programming language in the world because it runs in the most popular environment in the world, the web. It started as a simple scripting language to work with HTML forms, and it evolved into a language that not only enables us to interact with and manipulate websites, but we can also use it to build complete web and desktop applications. Hi, my name is Jeremy McPeak, and in this series of videos, I'm going to teach you some of the best practices that you should follow as you write your web or desktop applications. We're going to begin with the language's syntax. We'll talk about exciting things like semicolons, or more accurately, JavaScript's automatic semicolon insertion. We'll talk about where you should put your curly braces and why that actually matters. You'll look at equality, variables, functions, avoiding globals, and strict mode. From there, we'll move on to how to create objects. We'll look at the different creational patterns such as singular objects with object literal notation, factories, prototypes, constructor functions, and yes, even classes. You'll learn how to implement true privacy with features from ES2015, as well as creating immutable objects. We'll also look at how this works in JavaScript. Then we will examine modules. You'll learn about the basic and revealing module patterns, and we'll finish the discussion with native modules from the ES2015 spec. We'll move on to using JavaScript in the browser. I'll talk about decoupling your JavaScript from HTML and CSS, and we'll also look at how you can limit the amount of changes you make to the DOM. And then finally, we will talk about Node and NPM. I'll show you how to use ESLINT to lint your code, and we will use Webpack to bundle our code both for the browser and the server. We will end the series with a discussion on your Node application's configuration, or more specifically, how you should use environment variables to store your application's config. In order to follow along, you will need a code editor. Now, there are many code editors to choose from, such as Atom, Brackets, and Sublime. I am using Visual Studio Code, which is, in my opinion, the best editor for writing JavaScript applications, but feel free to use whatever code editor that you want. You'll also need a modern browser, such as Google Chrome, Microsoft Edge, Firefox, Brave, or Opera. I use Chrome most of the time, but just like your code editor, use the browser that you want. Now, I assume you are familiar with JavaScript. You don't have to be a master, but you do need to understand the basics. Things like the syntax rules, how to create variables and functions, and how to work with objects. You'll also need to know how to interact with the DOM, but that's about it. JavaScript has a feature called Automatic Semicolon Insertion, or ASI for short. And it does what its name implies. It inserts semicolons into our code, and it does so when it encounters certain grammatical errors. Now, what do I mean by grammatical errors? Because this is JavaScript, this isn't a spoken language. Really, it doesn't matter if it's a programming language or a spoken language. There is grammar, because that defines how we structure our statements. For example, whenever we want to create a variable and assign it a value, there is a certain grammar involved. We have to use the var keyword or the let keyword, followed by some white space, and then the identifier that we want to use for the variable name. And if we deviate from that rule, then we are going to end up with a syntax error. So if we have var x and then space and then y, that's obviously not going to work. So there is grammar involved with JavaScript. And when it comes to ASI, there are three rules that JavaScript uses in order to determine if it is going to insert a semicolon. The first says that as the code is being read from left to right, if it encounters a line terminator, which is a carriage return, or a closing curly brace, and I'm going to refer to those two things as a terminator token. So as the code is being read from left to right, if it encounters a terminator token, it's going to look at the code that comes after that terminator token. And if it doesn't make grammatical sense, it's going to insert a semicolon before that terminating token. So here we have two lines of code. We have var x, and then on the next line we have y equals 10. So as we are starting to read the code, we see var x, and then we see a line terminator. And because we encountered that token, we need to look at what comes after it. Well, it is simply y equals 10. So we can essentially simplify those two lines of code into this. So it doesn't make sense grammatically for y equals 10 to come immediately after var x. So we are going to insert a semicolon. And that's exactly what JavaScript does. In the case of this code, we have var x and then a semicolon. And then it continues to read our code. Y equals 10, well, that makes obvious sense. So that is going to be considered another statement. So even though this looks like it wouldn't work, it actually does. And we can prove that by saying console log x and console log y. And whenever we run this code, we're going to see undefined and 10 for x and y, respectively. Well, what happens if we do this? Let's put the value of 10 on another line. So we already know that after var x, there's going to be a semicolon. So we continue reading y equals. There is a terminator token, so we look at what comes after that, and that is simply the value of 10. Once again, if we simplify this, which it already was, then we know that it makes grammatical sense for the value of 10 to come after the equal sign, because that means that we are assigning the value of 10 to y. And the same would be true if it were an expression. So if we had plus 10, and then even on another line, if we had plus 20, then all of these make sense, and the value of 40 would be assigned to y. And we can see that that is the case in the console. Remember that I said that the terminating token can also be a closing curly brace. So let's look at an example for that. And the easiest way to do that is with a do while loop. We are going to increment y, and then we are going to write that new value to the console. And then we're going to do that for as long as y is less than 50. And this code is valid, and it will execute. And we see those values in the console. But notice that there is not a semicolon after console.log. So as we are reading the code, we have do, opening curly brace, we increment y, then there's a semicolon separating those two statements, but the second statement doesn't have a semicolon, but we encounter this closing curly brace. What comes after the closing curly brace is grammatically correct, so we insert a semicolon before that terminating token. So the semicolon is actually inserted there. And of course, as we run the code again, we see the same results as before. So we've looked at where this would work, but we haven't looked at where something like this would fail. Let's get rid of this do while, and we are going to use it here in a few moments. And instead, let's have an array literal. Let's have some elements in that array, and we're going to call the for each method. And in our callback, we are simply going to use the value, and we will write that value to the console. Now, whenever I save this and run it, we're going to end up with an error. It says that it cannot read property 3 of undefined. Now, the reason why we are seeing this is because there is not a semicolon separating the call to console log on line 8 and then the array literal on line 10. Because as JavaScript is reading this code, it sees that there is a terminating token at the end of the line, so it starts reading the rest of the code to see if it makes grammatical sense. If we simplify this like that, it does make sense. We know that console.log does not return an object, it doesn't return an array or anything like that. But JavaScript doesn't know that until the code is executed. So as it is just reading the code, checking for syntax errors and things like that, this makes sense. The log method could be returning an object, and it is perfectly valid to use the square brackets on an object. The same would be true for an array. In order to fix this particular error, we need a semicolon, and we can put that really any place in between the call to console log on line 8 or the code starting on line 10. So we could put that there at the end of the line 8, or we could also put it at the beginning of line 10. Either way, we would end up with the results that we would expect. We iterate over that array, writing each value to the console. That's the first rule. And that's probably the most difficult rule, because Rule 2 is really quite simple, and Rule 3 is simple as well. Rule 2 says that at the end of our code, if everything is okay, there's no syntax errors or anything like that, and if the program does not end with a semicolon, it's going to insert one. We know that this code works, although right now it wouldn't because we haven't defined why. So let's go ahead and do that. If we omit the semicolon at the end of the statement, we see that it works. And that's basically all that rule is. As long as the code is valid, there's no syntax errors, it is grammatically correct, then it is going to insert a semicolon at the end, and that is that. So we can move on to Rule 3, which is actually also quite simple, but if you were reading the specification, it's not very clear. Basically, there are certain statements that if they are followed by a carriage return, it doesn't matter what comes after that, then a semicolon is automatically inserted. And they are primarily keywords. One is continue, and if continue is one, then it makes sense that break is another. The return keyword, as well as throw. But it's also true for lambda expressions. If you put a carriage return between the parameter list and then the arrow operator, then it's going to insert a semicolon after the parameter list, and that is, of course, going to break your code. So if you plan on using an arrow function, you need to make sure that the parameter list and the arrow operator are on the same line. And the same is true for the yield keyword. You would be yielding something, and if you have a carriage return immediately after the yield, then it inserts a semicolon. Now that we know these rules, we get to talk about what is the best practice when it comes to semicolons. Basically, it falls down to two groups. There are some people, and I would say that the majority of people say that you should use semicolons. And then there is another group of people that say that it's okay as long as you are aware of what these rules are and your code works. I recommend that you use semicolons, and there's three reasons. The first is for style. JavaScript has a similar style and syntax to other C-like languages. So C, C++, Java, C#, PHP, all of these languages, of course, do have some differences, but the basic syntax is the same. And they all require you to terminate your statements with a semicolon. To keep in line with all of those other languages, it makes sense to use semicolons in JavaScript. The second reason is because if you do use semicolons and you happen to forget to use a semicolon somewhere and that causes a bug, it's easy to find that particular problem because it's the only statement that doesn't have a semicolon. So it makes your code easier to debug in those circumstances. But most importantly, programming is hard. It's difficult enough without having to think about if you are formatting your code correctly in order to get around using semicolons. Because that is what you would have to do. You would have to keep these three rules in mind as you are writing your code. So ultimately, it's just easier to use semicolons. JavaScript is a language that borrows a lot of its syntax from C and C-like languages. And one of the defining features of C is that the code blocks are delimited by opening and closing curly braces. So I'm going to create a function called createObj. It's going to accept two pieces of information, x and y, and then the body of this function is going to be contained within the opening and closing curly braces. And of course, we can use these curly braces anytime we have multiple statements that we want to execute for a particular control structure, like an if statement. So if true, then we could have multiple statements in here that would, of course, execute. And if for some reason true was not true, then we would have our else block, and everything inside of the opening and closing curly braces for else would also execute. In fact, just about every control structure, be it an if statement, a loop, try and catch, everything uses these curly braces. And like C and other C-like languages, for the most part, we have free reign as to where we can put the opening curly brace. Some developers like to put the opening curly brace on the same line as the statement, as you see here, Other developers like to put the opening brace on a new line. And for the most part, that's okay. It's not going to impact the way that your code executes. But let's go ahead and let's return an object here. So I'm going to use the return statement, and I'm going to use an object literal. We're going to have a property called X and a property called Y. And never mind that my code editor is automatically marking this as invalid. But whenever we save this, we see that there is a syntax error. There is an unexpected token, the colon. Now, in older browsers, we wouldn't get a syntax error. The code would execute, and whenever we would call this function, let's just say var obj equals create obj, we'll pass in 1 and 2, this would return undefined. Now, the reason why it would return undefined is because of a wonderful feature called automatic semicolon insertion. One of the rules states that when there is a return statement, if there is a carriage return immediately after the return statement, then it will automatically insert a semicolon before that carriage return. So what we essentially end up with in this case is that code. We are returning undefined. And in older browsers, this could be a bug that would be difficult to find because we wouldn't get an error or anything like that. It would just execute and we would get an invalid result. Or at least as far as our thought process is concerned, it would be invalid. But thankfully today, this is a syntax error. And the way that we can fix this is to just put the opening curly brace on the same line as the return statement. So whenever we run this, the syntax error goes away and we return an object that has X and Y properties. Because of this particular rule, it makes sense to put the opening curly brace on the same line as the statement every time. Because it doesn't matter who you talk to as to what type of style that they use, the main thing they are going to say is be consistent. Because we are forced to follow this style, we need to go ahead and use that style everywhere else for the sake of consistency. It makes our code easier to maintain, and it makes it easier for other people to read and maintain our code. So when it comes to curly braces, put the opening curly brace on the same line as the statement. That's the best practice to follow. Just like every other programming language, JavaScript has an equality operator so that we can check to see if two values are equal. And we also have the inverse. We have the inequality operator, which of course does the exact opposite. So let's have a couple of examples. We have A is equal to B. That of course is going to be false. But let's also use the inequality operator. And we can see on the right-hand side, we get false and true. Those are exactly as we would expect. Now, JavaScript's equality and inequality operators behave like you would think that they would as long as you are working with values of the same type. So in this case, var A and B are both numbers. So it's just performing a straight up comparison and we get the expected results that we get. However, let's introduce a third variable C, and then let's perform a comparison. We'll say A is equal to C. Now, in this case, we are going to see true on the right-hand side of the screen. This is where things begin to deviate from other programming languages. In JavaScript, the equality operator looks at both operands. If they are of the same type, then it just performs the comparison. However, if they are of different types, which in this case, var A is a number, var C is a string, then JavaScript is going to coerce those values to the same type before it performs its comparison. So this, in most other programming languages, would be false, because A is not equal to C because they are of two different types. Most of the time, you don't want to use the equality and inequality operators. There are some uses for them, but 99.9% of the time you don't want to use them. Instead, you want to use what's called the identity operator, which is simply 3 equal signs. And then we also have the not identical operator, which is an exclamation point followed by 2 equal signs. And the main difference between the identity and the equality is that the identity operator looks at both the type and the value. So there's no coercion involved. If the operand on the left is of a different type than the operand on the right, then it's false. because two values of two different types cannot be identical. And of course, the reverse is going to be true for the not identical operator. If the two operands are of differing types, then of course that's going to be true. So the majority of the time, you will want to use the identity and the not identical operators, because most of the time you want to check if both the value and the type are the same. Unlike other aspects of the language, when you start talking about variables and the best practices for variables, well, things become more subjective. You will find some developers that say that you should declare your variables in one way, then you will find another set of developers that say that no, that's wrong, you should do it this way. And that doesn't even touch the discussion between should you use var or let, because that is also highly opinionated. We're going to examine some of the ideas as far as what has been presented as the correct way of how and where you should declare your variables, and then I will give you my recommendation. Because really, there is no best practice here other than be consistent, but it doesn't hurt to look at all of the main opinions. So we're going to start by writing a function called sum, except that this is going to do something a little different. We're going to check to see if a is a negative value. And if it is, then we are going to create a temporary variable where we will multiply a by -1 so that it will be a positive value. Then we will save our result equals temp plus b, and then we will have an else statement. If a is 0 or positive, then we are just going to say result equals a plus b, and then finally return result. Now, for anyone new to JavaScript, either new to programming in general or new to JavaScript but coming from some other language, this could be a little confusing, primarily because of line 4. We have declared a variable called result, and we have used it inside of the if statement. But if we're looking at this logically, we would think that, okay, we have some code contained inside of this code block, and we are using this same variable throughout the rest of our function. That must be an error, and that's not the case. And I can prove that by saying console log, we will call sum, pass in 1 and 2, and we will essentially do the same thing, except that we will pass in -1 and 2. And over on the right-hand side of the screen, we will see the value of 3 both times. Now, the reason why this works is because when you use the var keyword, JavaScript does not have any block level scope at all. It doesn't matter where you declare your variable, that variable can be used throughout the entire function. Because as JavaScript is reading the code, it finds those variable declarations and it moves the declarations to the top of the function. We call this hoisting. Even though I've written the code like this, JavaScript transforms it to this: var temp, var result, and then inside of the if statement, it simply uses those variables. Because of this, there are some prominent voices that say that we should write our code like this, because this way there's no confusion. We declare our variables at the top, and then we use those variables throughout the rest of the function, because that is, after all, what JavaScript is going to do anyway. And I can somewhat agree with that, but I also don't like that particular style. And I'm not alone. There are many other developers that don't like writing this code in this way. Instead, I prefer to declare my variables where I would need to use them. So by all means, if you want to write your code like this, feel free to do so. There are many developers that think that this is the correct way to go. Just be consistent and do it all the time. Now, if I personally were writing this code, it would look like this. I would declare result outside of everything else, and then I would declare temp inside of the if statement. The reason being that even though I know what JavaScript is going to do behind the scenes, as far as the code is concerned, this implies that result is going to be used throughout the entire function, whereas temp is only going to be used inside of the if statement. I like this style for two reasons. For one, it makes the code easier to understand as a whole, at least in my opinion, because you have a sense as to where the variables are used. And that leads into my second reason. If you're coming from another programming language, then chances are very good that that language has block level scope. And so you would have written this code just like this in that other language. So it makes sense to carry that over into JavaScript. But as I've also said, this whole talk about variable best practices are subjective. The key thing is to pick what you like and stick with it. There's one other camp as far as using the var keyword, and that is to simply declare your variables the first time that you use them. So we're back to the first iteration of this code, where the temp and result variables are declared inside of the if statement. And that's fine for you to do. However, I'm willing to wager that this is the minority camp. Most developers are going to either declare their variables outside and at the top of the function, or they are going to do what I do, and that is declare the variables according to how they are going to be used. Now, let's throw a wrench into this whole discussion, and that is the let keyword. The wonderful thing about the let keyword is that it lets us declare a variable that has block level scope. So by saying let temp, this means that we can only use this temp variable inside of this if block because that is the scope of that variable. In fact, if we try to use temp outside of the if block, we're going to run into a reference error. It simply says temp is not defined. Now it is defined, but inside of that if block. So if we wanted to use another temp variable, we would have to declare that variable again. As far as the let keyword is concerned, there are two camps. There is the camp of people that say that let is the new var, so use let all the time now. And then there are other developers that think that it depends. Use let where it makes sense to do so, use var where it makes sense to do so. I am of the former. I believe that let is the new var, because that also falls in line with the way that I like to write my code. So I would say let result, and then I would use the result variable throughout the entire function. And then inside of the if statement, I would say let temp. This is my recommendation. I recommend that as you are writing your code, use the let keyword to declare your variables and declare your variables where it makes sense to do so. If you need to use a variable throughout multiple code blocks, then define that variable outside of the code block. But if you need a variable inside of a code block, declare that variable using the let keyword inside of that code block. That does not mean that you can just go to all of the JavaScript code that you've written before and replace var with let. Because let's look at why that could be problematic. Let's say that we go back to our first iteration, where we have our variable declarations inside of the if statement. Now, if we say let temp and then let result, we're going to get what looks like the same result on the right-hand side of the screen. But in actuality, we have introduced a bug. So the first time we call the sum function, we pass in two positive values, 1 and 2. So the code inside of the if statement is not going to execute. Instead, we're going to go to the else statement, where we say result equals A and B. We've just created a global variable here because we did not declare it with var or let. So we've created a global variable and we are returning that global variable. So the first time we execute the sum function, we've created a global result variable of 3. The next time we call the sum function, this code is going to execute. A is a negative number, so we are going to create the temp variable. We create this result variable, but this result variable is also contained within this if statement. By the time we get to the return statement, we are still returning that global result variable. And we can prove this by just changing our first call to sum. Instead of passing in 1 and 2, we'll pass in 1 and 3. And so we see the return of 4 both times we call the sum function. So you just can't go back to your old code and replace var with let, unless if you've written your code like this, just as you would have in another programming language, in which case your code would behave the way that you would expect it to. So we can check that by changing our first call to sum again. The first value is 4, the second is 3. To close this video, my recommendation is that you always use the let keyword to declare your variables, and you declare your variables where it makes sense to do so. JavaScript gives us at least 4 ways to create functions, but really there's only 3 that we use in our code. The function declaration, the anonymous function, also known as a function expression, or the arrow function. and we can sometimes refer to that as a lambda expression. Now, when it comes to the best practices for functions, there is one thing that you should always do, and that is define your functions before you execute them. Now, I know that that sounds rather obvious, but let's look at this. I've written a function called sum1, and I used the function declaration syntax. Now, with a function declaration, we can actually execute that function before we define it. On the right-hand side of the screen, we see the value of 3. The reason why we see this is because as JavaScript is reading our code, it finds the function declarations and moves them to the top. So it's hoisting those functions just like it does variables. However, unlike variables, where it is just the variable declaration, the entire function is hoisted to the top. So essentially, we end up with code that looks like this. We have our function at the top and then our execution. Now, there are some cases where that doesn't work. For example, if we define a function inside of an if statement or some other code block, like a for loop or something like that, then we're going to run into an error. So if I move sum1 inside of this if statement, then we get a type error. Sum1 is not a function. And in a future version of JavaScript, this could be an error before you even attempt to execute that function. So as a general rule of thumb, define your functions before you execute them. Now, the reason why we want to do that is because with anonymous functions and with arrow functions, we actually have to do that. Let's write a sum2 variable, and we will assign that an anonymous function where we essentially do the same thing as sum1. We take a and b and return the sum. And if we try to execute this before it is defined, then we are going to see a reference error. Because whenever we try to execute sum2 on line 5, the sum2 variable exists because that has been hoisted, but it is undefined because it's just the declaration. It hasn't been assigned this function object. So in order for this to work, we have to define sum2 before we can execute it. So get in the habit of defining your functions before you execute them. Another thing you need to be mindful is that as you are writing your code and you define a function, you are essentially creating an object. And function objects are different from other objects in JavaScript in that they don't really change. We define a function to perform a very specific piece of work, and we never change that function. So let's look at this. I'm going to write a function called init. We're going to accept an element object. We're going to set up that element object with some event listeners. So we will call the add event listener. We'll set up a click event listener, and then we will pass in our function that will handle that event. And let's do the same thing for another event. Let's just choose the mouse over. Let's follow the process of executing the init function. And I'm going to pass in something that doesn't exist, but let's assume that foo is an element object. So we call the init function. We set up the event listener for the click event. We pass in a function. We've just created a function object, and we've passed that to add event listener. And then we set up the event listener for the mouse over event. And once again, we create a function object and pass that to add event listener. Then we also want to initialize another element. So we call init again, we pass in another element, and we go through the same process again. We set up the click event listener, we create another function object that is going to perform the same exact work that it did whenever we called it the first time, but it is a different function object. In this case, we're doing more work than what we really need to do because we are creating these function objects, and we are also using more memory than we really need to. Because for every one of these function objects, we are creating them and then storing them so that they will execute whenever we click on an element. In cases like this, where it is convenient to use a function expression, it's better to define those functions beforehand so that you only create one function object and you reuse it every time that you need to. So we'll say that this is the element click handler. And inside of this function, we would do whatever work we needed, and we would pass element click handler to the add event listener method. We would do the same thing for the mouse over event. So we would define our function. We could use the declaration syntax like I'm doing here, or we could also use an anonymous function if that's what we wanted to do. Either way, we will essentially end up with the same results. We will have a function object that we create only once and we reuse wherever we need to. But you could use whatever style that you wanted to. And then we would pass that to the add event listener for the mouse over event. So as you're writing your code, keep in mind, functions are special objects. If you need to create multiple function objects to do the same work, then that's a good indication that you need to just define a function for that particular case. There's one other thing that we need to talk about, and that is the arrow functions. Arrow functions are so new that it's hard to think of any quote unquote best practices for them. However, I will say this. They were originally added to the language so that we could write very simple functions. In the case of our sum functions, it would be very easy to use an arrow function to perform that work. I know that they are the new thing to have, and everybody wants to use the new things, but the intention for arrow functions is so that we can write simple functions using a simple syntax. They're not really designed to serve as methods on an object, but they do a fantastic job of making simple functions easy to write. Many of JavaScript's best practices are subjective. They are based upon the opinions of other developers, and developers are people, so therefore every developer has their own opinion, and we typically have no qualms about voicing our opinions. But there is one thing that we can all come together on, and that is we should avoid the global scope as much as possible. Because if we write our code in the global scope, then it is globally accessible and thus it can be tampered with. Now, there are some cases where we want to make our code globally accessible. Like if we are writing a library or some dependency that's going to be used by other people or it's going to be used in other parts of our application, then we want to make that globally accessible. Otherwise, we wouldn't be able to access it. But for the most part, we want to completely protect our code so that it cannot be tampered with. So we're going to create a couple of variables. We're also going to write a function, and then we are going to protect them. Let's have our message that says that this should be protected. And we are going to write this message to an element that is inside of this HTML file. It simply has an ID of message container. So let's create a variable and retrieve that element. So let's just call the variable message container. And we will say document get element by ID, and we want that ID. So then we will have a function that's going to set the message, and we will have a value that we will then say message container dot inner HTML equals value. And then finally, we will have set message, and then we will pass in message. Now, this is a lot of code to do something very simple, but the idea is that we have a lot of code that we want to protect. And the easiest and best way to protect this code is to put it inside of a container that has its own scope. Like, for example, a function. We have this set message function, and anything that we define inside of this function, say a variable called foo, that cannot be accessed outside of the function. So, what we can actually do is take our code and put it inside of what we call an immediately invoked function. Basically, that means that we are going to define a function and then invoke it. So the first thing we want to do is have a pair of parentheses, and then inside of that parentheses, we will have our function expression. The reason why we want to use these parentheses is because it's a syntax error to have a function expression and then try to execute it. So instead, we can get around that by wrapping our function expression with parentheses and then calling our function. Now we can also put the calling set of parentheses inside. There really is no best practice for this. You will, however, find developers that have their own opinion about it. But the important thing is we have our immediately invoked function, we'll paste in our code, and so now we have code that is completely protected. So we can say that this is protected. And if we run this over on the right-hand side of the screen, we see that the message is written to the page. One of the very nice things about an immediately invoked function is that we can use the parameters of this function in order to inject dependencies. Like for example, if we want to use jQuery, we can have a parameter called the $sign. We can pass in jQuery to our immediately invoked function, and now we can be sure that whenever we use the $sign inside of our immediately invoked function, it is going to always refer to jQuery, because believe it or not, jQuery is not the only library that uses the $sign. And this is also nice because if we have a dependency with a really long name, then we can give it whatever name that we want to just by specifying the parameter. So if we wanted to call our really long named dependency X, we can do that without any problem. Now, of course, we don't have these things, so let me comment that out. But that's the basic idea. And with this pattern, we have code that is completely protected. There's nothing outside of this immediately invoked function that can tamper with this. So use this pattern. It is the standard way to avoid the global scope. ECMAScript 5 introduced a new feature called strict mode. It gives us a way of opting in to use a more restricted version of the JavaScript language. And the reason why we would want to do that is because strict mode fixes a lot of JavaScript's issues. In fact, it quite literally changes the behavior of some parts of JavaScript. Now, you can opt in to strict mode in one of two ways. You can do so for an entire script or for a function. All you have to do is the first statement in the script or in the function needs to be simply use strict. In this case, all of the code that's going to be inside of this file is going to be ran in strict mode. However, you typically don't want to do this on a script level because you could run into some issues. So instead, use an immediately invoked function, which you should be doing anyway in order to protect your code, and then make the first statement use strict. So everything inside of this function is then going to run in strict mode, including any nested function as well. One of the best things that you get with strict mode is that you no longer accidentally create global variables. This is something that I have done, and I know that every developer has done at some point in their life. They create a variable without specifying var or let, which is, of course, going to give you a global variable, which is going to potentially cause problems. Now, in strict mode, this is actually an error. You can see on the right-hand side of the screen that this is a reference error. Global variable is not defined. So in order to assign a value to a variable, you have to define it first. We'll use let here, and then the error goes away. Another nice aspect of strict mode is that whenever you use the parseInt function, it's going to default to a base 10 number. And that's typically what we use parseInt for. There are some times we want to parse to a different base of a number, but for the most part, we want to parse to a base 10. So we no longer need to specify the 10 radix. We can just call parseInt, pass in the string that we want to parse, and we are good to go. The next benefit is that inside of strict mode, we will be alerted to errors that we normally wouldn't be alerted to. Like for example, we have this nested function, and let's say that we make a mistake. We define two parameters with the same name. Now my code editor is automatically giving this away. But if we save this, we see that this is a syntax error. A duplicate parameter is not allowed in this context. If we take out useStrict, that error goes away. So what was once a silent error is now not silent, and that's a nice thing. And the same is true for if you want to delete or modify a property that is not deletable or modifiable. Like for example, if I try to delete object.prototype, we're going to run into an error there. Although our parameters are taking over as far as what's being reported, now we see that there is a type error. We cannot delete the property prototype of function object. And so it's nice to actually see that error now. It also protects what may be future keywords. For example, private. If we set this to something, it doesn't matter what we set it to, we're going to see a syntax error. If we take this out of strict mode, it's not an error. So private, protected, interface, there's a variety of new words that are protected inside of strict mode. That doesn't necessarily mean that they will ever be used, but they are being reserved. And then there's the with statement. With has been considered a bad practice for a very long time, but now inside of strict mode, you will get an error if you try to use with. It is prohibited to use in strict mode, so don't even try to use it there. Browser support for strict mode used to be spotty, but with today's modern browsers, feel free to use strict mode now every time you write code. It'll not only help you write better code, but it'll also help future-proof your code. JavaScript gives us many ways for creating objects, and how we create our objects really depends upon the object's purpose. Like for example, if you wanted to create multiple objects of the same or similar types to represent similar things within your application, then there are patterns for creating those objects. But a lot of times you just want a single object, and the best way to create a single object is using object literal notation. Now, there is nothing that says that you can't use the object constructor, but nobody does this. And there's no reason to do this because we get the same exact results with far fewer keystrokes. So whenever you need to create a single object that doesn't inherit from any other types of objects, just use object literal notation. So I've created an object called UI. The idea being that this is an object that we would use within our application to work with the different parts of our user interface. So for example, we would have a status, which would be an object, and then the status would have properties and methods for working with the status. And if we had a toast system, we could have another object called toasts, and then there would be properties and methods for working with those toasts. So for our status, let's say that we have an element in the DOM that represents our status, and we need to be working with that element. So we'll say underscore element, we'll set that to our element object, which the ID is status-element. And then let's also have a method for setting the status. Now you'll notice that I've used two different styles for the identifier names. Element begins with an underscore, and set status just looks like a normal property identifier. Let me first of all say this. JavaScript has properties. Everything you define on an object is a property. We logically have methods by referencing a function in a property, but it is still a property. So set status is a property, but we logically say that it is a method. So the underscore in front of element typically means that this is a private property. We haven't had true privacy in JavaScript until recently, and unfortunately, not every browser supports the features in ES2015 that give us the ability to use true privacy. Really, the next best thing is to just use the age-old convention of prepending your property with an underscore. Yes, it's not private, but it's there for you to use, and the underscore tells everybody else that this is private, please leave it alone. So we have our element object that we reference inside of our setStatus method. We set the inner HTML to the supplied value. So if we were going to use this method, we would say UI.status.setStatus, and then we would pass in a new status value. The really nice thing about object literal notation is that you can define an object all in one statement. This is one statement, it's a large statement, but it is still one statement. However, by using this syntax, we create objects that can be modified. For example, if we come in here and if we say UI.status equals null, and then we say UI.status.setStatus, this will fail. Of course, it's going to fail because we set status to null and we've tried to access a property on a null object. So if you're using object literal notation to create an object, you need to keep this in mind. Because while that may be just fine for some objects, for an application object like this UI object, this is unacceptable. We should not be able to modify any piece of the UI object. So when it is absolutely critical for you to protect properties on an object, you don't want to use object literal notation to define those properties. Instead, the best practice is to use object.defineProperty so that you can provide what's called a descriptor, which is an object that describes the property that we are defining. So whenever you call the defineProperty method, the first argument is the object that we are defining a property on, so UI in this case. The second is the name of the property that we are defining. And then third, our descriptor object. Now, there are many options that we can set here, but in this case, we're going to set two. The first is the value, and we can assign this whatever value that we want. If we wanted the value of 10 or a string value or anything, we would do that here. In our case, we want just an object. And then the other option is called writable. Now, if we set this to true, then we end up with the same problem that we had before. However, if we say false, well, we have just created a read-only property. So if we come in here and if we say status is equal to null, and then we write to the console UI.status, we're going to see object. And there that is. And this is problematic because, there are other things that we want to define on the status object itself. So we can't come in here and say status equals and then define our object because status is read only. We can, however, say status dot underscore element equals and then the value, but we run into the same problem. Our underscore element property is writable, so we could set that to null, and then we lose the functionality of that property. So instead, what we want to do whenever we are defining our status property is we want to define our value as a property, but we also want to define all of our other properties, if that makes sense. If that doesn't, this will. We will call a method called defineProperties, which is very similar to defineProperty, except that this allows us to define multiple properties at one time. Now, the object that we are going to pass is going to be simply an empty object, because the defineProperty and defineProperties method returns the object that you pass to it. So we are essentially going to say that the value of status is going to be this object that we are passing to defineProperties so that we can define the properties that we want on our status property. So the defineProperties method accepts the object that we want to define our properties on, and then the second argument is another object that contains our properties and their descriptors. The first is going to be underscore element, and then for this property, we define the descriptors. So we say value is going to be document get element by ID status element. We want to set this to be read only, so we will say writable is false. And then we will do the same thing for set status. So we have the property name and then the descriptor. The value is a function that accepts a value. Where we access our element object, we set its inner HTML to the value, and we want to protect this as well. So we say writable is false. This is, of course, a lot of extra code that we have to write. But in order to protect our properties, this is what we have to do. So let's add one other thing here. We'll say console log, we'll say value, and well, we'll say string value is the value so that we can see that in the console so that whenever we call it the first time, we see that we have a new status value. And after we set status to null, which of course isn't going to work because status is read only, we call set status again, and we see that status in the console. Now, one other thing, we aren't in strict mode, which we should be now. So let's go ahead and say use strict. And whenever we run this code, we're going to see a new error. Whenever you are in strict mode and you try to assign a value to a read-only property, you get an error. Cannot assign to read-only property status of object. So this is another reason why you want to use strict mode whenever possible. It can help you catch bugs that would be difficult to find otherwise. So whenever you want to define a single object, use object literal notation. But if you need to protect the properties on that object, use the define property and define properties methods on object to define those properties and set their writable options to false. Yes, it is more code, but your application will be better off because of it. There are a couple of different ways that we can create multiple objects that either serve the same or similar purpose, or they have the same or similar type. What do I mean by that? Let's say that we are building a system where we need to work with people. And one of the best ways to organize and work with that information is with objects. So let's say that we are going to have what we would call a person object. It would have a first name property, which in this case will be John. And then we would also have a last name property, which for this object will be Doe. And we have a person object. We also want to work with other people as well. So let's say that we have a Jane Doe, and we will follow the same steps. We will create an object that has a first name and last name property. While these objects don't technically have a type other than object, we could say that if it has a first name and a last name property, then this is a person object. And this is relatively simple to do. But of course, this isn't something that we want to repeat over and over and over again every time that we needed to create a person object. So one of the things that we could do is write a factory. And in its simplest form, a factory is nothing more than a function. And we could call this factory a variety of different things. We could see create person being a good name for this function. We could also say that this is a person factory. And we could make this factory as simple or as complex as it needed to be. But since we are just creating a person object with first name and last name, that's really the only information that we need to pass to this factory. And we can do that as well in a variety of different ways. We could pass in an object that has the first name and last name properties. But if we go that route, then we kind of lose some of the benefits of using a factory, because one of the things that a factory allows us to do is to create objects with as little code as possible. So instead, we can just pass in the first name and last name, and then this factory will simply return new object that has first name set to first name and last name to last name. If our browser supported it, we could just say first name and last name. And so now, in order to create our John Doe and our Jane Doe objects, we would simply call this factory function. So we would say person factory, John, and the last name of Doe. And then we could do the same thing for Jane Doe. So we would simply call person factory and then pass in the information for Jane. The benefit to a factory grows in accordance to the complexity of the objects that we want to create. For example, our person objects as they are currently are rather simple. So the benefit to using a person factory really isn't that apparent until we create a lot of person objects. But now let's say that this object needs to have some type of behavior. Let's have a method called greet, where we will accept a person and we are going to greet that person. So we will say hello, and then we would get the person's name. Let's go ahead and say that we're going to have a full name property. So let's add a getter here. We'll say full name, and this is simply going to return the first name concatenated with a space, and then the last name as well. So the more things we add to this object, the greater the benefit is of creating these objects with a factory. And once you simplify the way that you create objects, you can then do much more powerful things, like create a factory that relies upon another factory. Like, for example, we not only want to create just individual people, but we want to create specialized people, like an employee. So we will have an employee factory that is going to have the first name and last name of that employee. But we will also have the position of that employee as well. The great thing about having our person factory is that we can rely upon that to create our basic person object. Now we can say that we have an employee who is, hopefully, a person, and we will pass in first name and last name, and that will give us the basis for our employee. So that now all we have to do is say that the employee's position is equal to whatever was passed to the factory. And if we wanted to, we can even override the greet method because an employee should greet a person a little differently. So let's save the current greet method. We can say employee.greet because we still want to be polite and say hello and then the person's name. But then we also want to ask that person if we can help them. So we will say employee.greet. We will set that equal to a function that accepts a person. We are still going to call the old version of greet. We need to pass in person there so that we can properly greet them. But then, how may I help you? And of course, one thing that you would probably want to do is protect all of these properties that we have been creating, like the first name, the last name, full name. All of these we could define using object.define property or object.define properties. I'm choosing to go this route because it's much simpler and it's a lot less code on screen. In a real system, if these were objects that I wanted to protect those properties, then I would definitely define all of those properties correctly with the define property and define properties methods. So let's create an employee and we'll call that employee Jason Smith. So we will say employee factory. We will pass in Jason as the first name, Smith as the last name, and then the position. We can say that this is the sales manager. And so Jason is going to greet John. So let's write this to the console that we can see it. We'll say Jason Smith will greet John Doe. And over on the right-hand side of the screen, we see an uncaught type error, cannot read property greet of undefined. And that's because we need to return employee inside of our employee factory. So now we see, hello, John Doe, how may I help you? So when you need to create multiple objects, especially complex objects, the factory pattern is a good solution. It's one of the best ways for creating complex objects. And once you simplify the way that you create objects, you can not only create those objects much easier, but you can build upon them to build even more complex objects. Whenever you are creating multiple objects, it's important to remember that every property that you define on every object that you create consumes memory. Now, I know that that sounds rather obvious, but there's one thing that we tend to overlook, and it's just primarily because JavaScript is different from other object-oriented programming languages. And that is that JavaScript does not have methods. We have properties that refer to functions, and in JavaScript, a function is an object. So anytime that you write a function in your code, you are essentially creating a function object that is going to consume memory. So just as an example, I wrote a function called personFactory. This is an object that's going to consume memory so that any time that we wanted to execute this function, we could by using its name and executing it by passing in the first name and last name values. As its name implies, this is a factory function, so we are going to create an object that will have first name and last name properties. Let's also have a greet property that's going to essentially be our method. So from here on out, I'm just going to refer to it as a method because that's logically what we have. So this is going to return hello and then person.firstname. So it's a very simple object, but it has a problem. And let's create a couple of objects so that we can see what that problem is. So the first one is going to be called John Doe. We're going to pass, of course, John as the first name and Doe as the last name. But then let's create another object that has a completely different name so that we have two different values for first name and last name. This one will be Jane Smith. So we end up with two objects that have different values for first name and last name, and that's fine because that's what those properties are for. However, when it comes to the greet method, well, we end up with two separate objects that refer to two separate function objects for greet. And that's not such a good thing because a function is rather static. We write a function to perform a specific task, and we rarely ever change that function. We end up with two function objects for the greet properties, and that means we are consuming more memory. So if we write to the console, johndoe.greet is equal to janedoe.greet, we're going to see the value of false. Well, actually, we see a reference error because I typed the wrong object. So there we go. We have false. And it doesn't matter if you use the equality or the identity operators. We're going to end up with false because the greet method on John Doe is a different object than a greet method on Jane Smith. So if we create 1,000-person objects, they are going to have 1,000 different functions for the greet method. And that's not really something that we want, especially if we are writing an application that's going to be running within a mobile environment. Now, for desktop computers and laptops, system resources aren't that big of a deal. We have a ton of processing power as well as a ton of memory. And those are the two things that we should be concerned with, because in order to create these function objects, we are using CPU time. In order to store those function objects, we are consuming memory. But on a mobile device, our applications are running within a browser that is sharing resources with a lot of other tabs. And that browser is also sharing resources with a lot of other apps and services running on that mobile device. And our mobile devices just have a limited amount of CPU and memory. So if there's anything that we can do to ease our usage of system resources, then that's something that we should consider. And we can approach this in a couple of different ways. But one thing to remember is that JavaScript is a prototypal language. And more often than not, if you are not embracing the prototype, you are writing inefficient code. We could rewrite this to be more efficient. The first thing we need is what is essentially going to be our prototype for our person objects. So let's go ahead and create that object. And I'm just going to call it person prototype. And in this object, we are going to define the greet method. And it is essentially going to be the same thing. So let's just cut this and paste it up here. The indentation needs to be fixed. And let's get rid of this trailing comma whenever we create this person object. We have our prototype for our person objects. And so whenever we call our person factory, the first thing we're going to do is create a person object based upon this person prototype. And we do that with object.create. And we will pass in person prototype, which is essentially going to use person prototype as the prototype for our person object. So this person object that we have just created now references this greet method that we defined on our prototype. And the only time that this greet method gets created is right here whenever we create our prototype object. So we have created our person using our prototype, but we can also define any other properties that we need to. So the first is going to be our first name. Let's go ahead and make this a read-only property. So we will say writable is false. The value is going to be our first name. And then we will essentially do the same thing for last name. So let's just copy and paste. Let's make the necessary changes, and then we will return person. Now, over on the right-hand side, whenever I save this, we're going to see that this is true. And that is exactly what we want. And these methods work as well. So if we call the greet method on John Doe and we pass in Jane Smith, we should see on the right-hand side the value of true, and then we should see hello Jane, and we do. But in doing this, we now have another problem. Our person prototype is out here in the global scope, and that's definitely not what we want, because this is going to be the basis of all of our person objects. So we want to protect this as much as possible. And we can do that with an immediately invoked function, but it's going to be a little bit different. We're going to create a variable called person factory, and we're going to set this equal to the result of calling an immediately invoked function. And then we will basically take our existing code and put that inside of our immediately invoked function, except that in this case, we want to return our other function, our factory function that does the actual creation. So we end up with something that looks like this, but we end up with the same result over on the right-hand side of the screen. Whenever this immediately invoked function executes, it creates this person prototype, and it's going to keep this in memory because this is a closure. We create it here, we reference in the function that we then return to person factory, so that this prototype object is now protected, and it's used every time we call our factory function. Now, I know that this requires extra code. It also requires extra thought. But the counter argument to that is that we are programmers. We are paid to solve these types of problems. Programming isn't easy. If it was, then everybody else would be doing it as well. So when you're creating multiple objects, look for the things that could be considered a prototype. Typically, it's things that don't change. Functions, getters and setters, anything that an object would need, but is never or very rarely modified. When it comes to creating multiple objects, a factory is the best option for creating simple objects. But if you need to create more complex objects, especially if those objects have a lot of methods, then a constructor makes more sense for a variety of reasons. For one, it falls in line with the other design principles already implemented in the language itself. Whenever you define a constructor function, you are essentially defining your own custom type. And JavaScript is a language that contains several built-in types like number, string, object, and so on. So whenever you write a constructor function, you are following in that pattern. But it also falls in line with other programming languages. You're defining a type, and then whenever you want to create an object of that type, you call the constructor using the new operator. And there are many, many other languages that have that same pattern. But it's also nice because prototypes are kind of built in with constructor functions. Every function object has a prototype property, but it's really only useful on constructor functions. And this is where you can define all of your methods. If we are creating a person constructor or a person type, a person could have a method called greet that would accept another person, and then we would simply greet that person. So hello, and then that person's first name. In many ways, that's a lot simpler than what you would do with a factory function. So there are some very good reasons why you would want to write a constructor function in order to create multiple objects. But there are some things that you need to keep in mind when doing so. The first thing is that you want to use the constructor to initialize your object and nothing more. So anything that's not required for your object to work, you don't want to do that in the constructor. Like, for example, we need first name and last name properties. The constructor is the perfect place to assign those properties their values. However, let's say that we have a method called run for our person. We don't want to call run inside of our constructor. First of all, it doesn't make sense to do so, but it has nothing to do with creating the object. Now, you might have a method that was involved with initializing other aspects of the object, and that's perfectly fine. But you only want to do the things necessary for creating your object and nothing more inside of the constructor. That's the first thing. The second thing is that you typically only want to define properties inside of your constructor. For example, it became rather popular to do something like this. We would have a method called getFirstName. We wouldn't have an actual first name property. Instead, we would have getter and setter functions for getting those values, and they would essentially create a closure around any local variables. So in this case, we're creating a closure around the first name parameter. And the reason why this is tempting is because it gives you an idea of privacy. It's not true privacy, at least in the sense of other programming languages, but it does protect that value from being modified outside of the constructor. So let's create John Doe. We want to new person, and of course, the first name and last name are going to be John Doe. Let's also create a second object. We will call this one Jane Smith. We will have Jane and Smith for those two values. So we have created two objects, but they have two completely separate getFirstName methods. Those methods perform the same work, they simply return first name, but they aren't the same function object. And that goes against the design principles of JavaScript itself. If you look at any of the built-in data types, all of the methods are defined on the prototype, which essentially means that all of the methods are shared between all of the objects of a given type. For example, even though these are person objects, they inherit from the object data type. So if we say John Doe.toString equals JaneSmith.toString. That's true because the toString method is defined on object.prototype. So when it comes to defining methods or method-like things, such as getters and setters, the best place to do that is on the prototype. So when it comes to privacy and the prototype, there are really only three options. The first is to create properties that begin with an underscore. This is the convention for saying that this is supposed to be a private property. Please leave it alone. And most developers are going to leave it alone. And then you could have your getter and setter methods for accessing those properties. Or if you wanted to have getter and setter properties that accessed those values, that would be fine as well. Now, another option would be to actually implement true privacy, and you can do that with the new features in ES2015. But then the third option is to just not care about privacy. And in this case, for this person object, that's really what we want. We want first name properties. We want last name properties. So there's really no need to have a getter method here. So we're going to create a method called greet. We will accept a person. We will return our greeting and then person.firstname. Now we can also define a getter property. Now to do this, we need to use the define property method. We will pass in person.prototype as the object that we want to define that property on. Let's create a full name property. And then for our descriptor, we will have a getter that is simply going to take the first name and concatenate that with the last name. So we will say this first name and then space and this last name. We could, instead of saying first name here, we can say full name, and that would be fine as well. When it comes to constructor functions and defining methods on the prototype, it's not as straightforward and wonderful as you might expect it to be, but it is the best practice. If a developer is writing constructor functions and thus creating their own data types, they typically love to inherit from other data types as well. So let's create a data type called employee that it's going to inherit from person. And we need first name and last name. We also need our position. Now, the first thing we need to do as per the inheritance pattern is call the person constructor as if it were this employee object. We want to pass in first name and last name so that those properties are created and populated with the values passed to employee. But then we also want to set the position property to what was passed to the constructor. So that's the first thing. The second thing is that we need to set up the prototype chain. And the best way to do that is with object.create. And we will pass in person.prototype. You might see some code that looks like this, employee.prototype equals new person. And that works. And that's what we used to have to do because that was the only way to set up the prototype chain. However, this pollutes the employee's prototype. Instead, we want to call object.create. In doing so, we create an object based upon person.prototype. It has nothing else other than what is on person.prototype. So thus we have a very clean prototype. So as a best practice, always use object.create when setting up the prototype chain. The second thing to be aware of is the prototype chain's length, because the longer the prototype chain is, the longer it could take your code to execute. For example, let's say that Jane Smith is an employee, and let's make her a manager, so that whenever we call the greet method, it's going to execute the only greet method that we have defined. So let's write this to the console. We will say Jane Smith greet, and we will pass in John Doe. Now over on the right-hand side, we see hello John Doe, so that works. But here's the thing. The greet method does not exist on the Jane Smith object itself. So the JavaScript engine is going to say, okay, I know that Jane Smith was created from the employee constructor. Let's look at the employee's prototype. Well, the greet method isn't defined there either. So it's going to look at the prototype of employee.prototype, which is person.prototype. And then it's going to find the greet method. So the longer our chain is, we could potentially be making our code take longer to execute because it has to go through each step in the prototype chain until it finds the method or the property that you're trying to access. Now, let's say that we define a greet method on employee.prototype, and we could do this in a variety of different ways. We could pass an object to object.create that would have all of the properties and methods that we want to define on the prototype. But in this case, this is a little more explicit, and we can just return howdy. So now over on the right-hand side, we see howdy. And this took less time to execute because the JavaScript engine didn't have to go all the way back to person.prototype.greet. It just had to go to employee.prototype.greet. So there are a few things to take away from this video. The first is a constructor function is responsible for initializing the object and nothing more. So do the work that you need to do to properly set up the object, and that's it. The second thing is typically only define your properties inside of your constructor. Define your methods on the prototype of that constructor. The third thing is if you plan on inheriting, when you set up the prototype chain, use object.create. And then the fourth thing, be mindful of how long your prototype chain is. ES2015 introduces a lot of wonderful new features to the JavaScript language, and one of them is the long-awaited class. Now, because classes are so new, I can't really say that there are many best practices, because what we call our best practices come from using a particular feature or pattern, and we just haven't had classes long enough to develop a set of best practices. However, classes in JavaScript are not like classes in a typical classical object-oriented programming language like C#, Java, C++, and so on. Instead, a class in JavaScript is really nothing more than syntactic sugar for defining a constructor function and then defining your methods and getter and setter properties on the prototype. So with that in mind, we can take the best practices from the constructor pattern and apply them to the class. So if we start with the constructor itself, we need to only do the things that are responsible for creating the object. So any properties that need to be defined need to be done inside of the constructor. We don't need to do anything that is not required for that object to work. Instead, we need to put that inside of a method and then let whoever is using our class call that method themselves. The second thing is that while we can define a method inside of the constructor, just like we could with a normal constructor function, we typically don't want to do that because every time we would create an object, the functions for our methods would have to be recreated over and over again. And while they would perform the same work from one object to another, they would be different function objects and thus consumed more memory. I know that it is tempting to define your methods inside of the constructor so that you can create closures around the data that you want to protect. However, if you are fortunate enough to be in an environment where you can use classes, then you can use some of ES2015's features for implementing true privacy. So if privacy is what you want, do it right. Don't do it by creating closures around the parameters for the constructor. The majority of the time, you want to define your methods outside of the constructor and inside of the class definition, because in doing so, those methods are going to end up on the prototype. So we will have our greet method here. We will return our greeting, hello, and then the person's full name. Now, we don't have this full name property, but we will define that, and we were going to do that outside of the constructor as well. And so this is just going to have a getter where we return this first name, and we will concatenate that with a space followed by the last name. And so if we inspect the prototype, we're going to see those two items. So we will write this to the console, person.prototype. Over on the right-hand side of the screen, we will see the get full name, and then we also see the greet method. We can also define static methods, which are methods that don't do anything with instance data. Like for example, our greet method doesn't do anything with the person class that we're working with. Instead, it does something with the person object that we pass to it. We can make that static because it's not an instance method, really. And by doing so, the greet method is no longer on the prototype. Instead, we would call it by saying person.greet. So as you are writing your classes, if you find methods that don't do anything with instance data, that's a good indication that it should be a static method. Now that's not always going to be the case, but that's also up for you to decide. Because we have classes, that also means that we can inherit one class from another. We will create an employee class that extends person, and our constructor is going to have the first name, last name, and the position parameters. And the first thing we will do is call super, which is going to call person. We will pass in first name and last name, and then we will create that position property. Thankfully, that's all that we need to do as far as inheritance is concerned. We don't have to call object.create in order to set up the prototype chain or anything like that. It's just automatically done for us. However, do keep in mind the length of your prototype chain. You don't want a huge chain for the same reasons why you wouldn't want a huge prototype chain using the constructor pattern. And if you are able to work in an environment where you can use classes, then there's no reason to use the constructor pattern at all, because classes are superior in every way. You get the same results with less code and cleaner code as well. Privacy is a very important part of any object-oriented language because that is what allows us to protect data from any outside interference. And in JavaScript, we have been able to implement privacy to varying levels of success, but they all had adverse side effects as far as memory usage is concerned. Well, with ES 2015, we have two new features that allow us to implement privacy and do so without any extra memory usage. The first uses the symbol data type, which is fairly easy to implement, but we end up with an implementation that isn't 100% truly private. The second is the weak map, which is a little bit more difficult to implement, but we end up with 100% true privacy. And we're going to look at both of these solutions because using a symbol might be good enough for you. It's just up to you whether or not you want to use that or not. We are going to make our first name and last name properties private so that they can only be changed from inside of the class itself, and we will add some getters to retrieve those values. With a symbol, basically what we want to do is call the symbol function. This is going to give us a unique value, which we can then use as a property name. We can say const, and we want to make these constant because we don't want these to change. And we will say first name symbol equals the call to the symbol function. We will do the same thing for last name symbol. And the reason why we would consider these to be private is because we don't have access to the value that this generates. Well, we do, but it's only within these variables. There is no actual property name here. It's just whatever value is generated by calling the symbol function. Now, we can pass in a string to the symbol function, but this is nothing more than a label, because we can pass the same string to both of these calls to the symbol function, and we will still end up with unique values. We will just say first name and last name, because if we ever enumerated over the symbols, we would then see what that symbol is essentially for. Like, for example, if we say console log first name symbol, then over on the right-hand side of the screen, we see symbol and then first name. So it's just a way of identifying that this symbol is for the first name property, this symbol is for the last name property. If we don't pass anything, then there's a little bit of obfuscation here. We see that it's a symbol, but we don't necessarily know what that symbol is for. And so that would give us a little bit of extra protection, but it's still not going to be 100% protected. So we have our first name symbol and our last name symbol. And basically, instead of saying this dot first name, we're going to say this, we're going to use the square bracket syntax, and then first name symbol. So this symbol becomes our property name. And we will use this syntax anytime we wanted to access the first name of our person. So we will do the same thing for last name. And then we will just need to change our code in the other places where we use those properties. And then we are going to end up with the same results. If we access the full name property, then we are going to still see John Doe for this John Doe object. So let's go ahead and do that. We'll say John Doe, full name, and over on the right-hand side, we see John Doe. Now, the great thing about using a symbol is that we can also use these properties inside of our static methods. And this is where we start to get close to being truly private, because a private variable is accessible throughout the entire class, including static methods. This means that on this person object that the greet method gets, we should be able to access any private variables, and we can. So if we wanted to just use the first name on this person, we could do that. So if we call person.greet and we pass in the John Doe object, then we are going to see hello John. Now we can write a couple of getters. We could call the first one first name, and we will essentially just return this and then our first name symbol. We will do the same thing for the last name property. This way we can access those values, but they are only getters. We're not setting any information. Now, of course, the symbols that we have defined right now are global, so we need some way to protect these so that they cannot be accessible in the global scope. What we can do is this. We can say let person equals, we will call an immediately invoked function, and inside of this function, we are going to define our symbols and define our class. We will paste that code inside of the immediately invoked function, and we will simply return person. So we still can create our person objects, but we no longer have access to these symbols. So if we try to write those values outside of our immediately invoked function, we're going to see that they don't exist. We are really close to true privacy. However, we can retrieve all of the symbols on a given object. So let's do symbols equals, we call object dot get own property symbols. Then we pass in our person object, and that gives us all of the symbols in that object. So we have symbol and symbol. If we had labeled these with first name and last name, then we would know what symbol is what, and we could retrieve that symbol by enumerating over this symbols array, and then we could access that data. This is where I say that it's easy enough to implement, but it's not truly private. However, anybody who wants to access that information outside of your class is going to have to know what these symbols are. It's not as easy as just using a string for a property name. So it's a little obfuscated, but it's not 100% perfect. So let's look at a perfect implementation. We're going to take the code that we have already written, let's copy it and paste it, and we're going to use that as the basis for our person2 class. So instead of using a symbol, we are going to create a weak map. We're going to call this private data, and we're going to new up the weak map constructor. Now, a weak map is a collection of key value pairs where the key is an object, and then the value for that key is weakly mapped to that key. So if we get rid of the object, then the value just goes away as well. We don't have to worry about any memory leaks or anything like that. It's just going to work for us. And we use it like this. Inside of our constructor, we're going to say private data. There's a method called set. We will pass in this as the key. And then for our value, it's going to be an object that has first name and last name properties. And so inside of our greet method, we have person and we changed that to return the first name. So instead, we're going to say private data. And in this case, we are getting information. So we're going to call the get method. We pass in that person object, and then we specify the first name property. Because the value that we assigned for this object is another object, so we can just say dot and then that property name. So for the full name, we are essentially going to do the same thing. We say private data get, we pass in this, and then first name. We do the same thing for the last name. So it's a little bit more involved than using symbols, but we end up with an implementation that is 100% private because there's no way then to access our private data. And then finally, for our first name and last name properties, we will just do the same thing. Instead of first name, we say last name for the last name property. Now we have John Doe. Let's say John Doe 2. We will new up person 2. And of course, we will pass in John Doe for those values. And then let's write some data to the console. So let's comment out these other 2 lines of code. And we will just say console.log. We could say person.greet. We could pass in John Doe 2, although in this case, we need this to be person 2. And we see hello John. If we try to access the full name property, then we are going to see John Doe. If we say last name, we see Doe, and so on and so forth. So when it comes to privacy, we have 2 options. We can use symbols for our property names, and that might be good enough for you. But if you want to have a rock-solid implementation of privacy, you want to use a weak map. There's no question that JavaScript is a different language from other object-oriented languages, but that doesn't mean that we can't take object-oriented ideas and concepts and use them in JavaScript. It just means that we might have to do some extra things in order to make it work. Like, for example, there are times when we want to create immutable objects. These are objects that don't change. So in terms of a JavaScript object, an immutable object can't have new properties added to the object. Properties cannot be removed, and the properties cannot change either. And we have the ability to create an immutable object with the freeze method. However, when you start talking about creational patterns, such as the factory, constructor, and classes, and you want to create immutable objects using these patterns, well, things become not as straightforward as you might expect. So we're going to start with a factory function. We're just going to call this createPoint. We're going to accept 2 values, x and y, and this is simply going to return a new object with those properties. So it's very simple and straightforward, and let's go ahead and create a point object. Right now, we have just a normal JavaScript object, but we can make this immutable by saying object.freeze and passing in our new object. This is going to give us an immutable object so that it cannot be modified. And if we try to modify this object, we're going to run into some errors. And in order to see these errors, we need to switch into strict mode. So let's go ahead and do that, which we should be doing anyway. So on the right-hand side, we see that we cannot assign a value to x because it's read-only. Let's say that we wanted to turn this point into a 3D point. So we will try to add a z property. Well, we're going to run into something similar. It says that we cannot add property z because the object is not extensible. Since this is a factory function, we could normally create another function, create 3D point, and we would accept x, y, and z. Normally, what we would do is create our normal point. So we would call createPoint and pass in x and y, and then we would modify this with a z property. However, this is not going to work because the object that gets returned from the createPoint function is immutable. So if you choose to use factory functions in order to create your objects, and you want to build upon those objects to somewhat emulate inheritance, you're going to run into a problem if you want them to be immutable, because you just can't get around that. While a single factory function works very well with creating an immutable object, using that object to build other objects isn't going to work at all. So instead, we can turn to the constructor pattern or the class pattern. And since they are both very similar, I'm just going to use classes. So we're going to create a class called point, and we will have our constructor where we get x and y. And of course, we are going to set this.x to x and this.y to y. So once again, it's very straightforward. So now for our point, we will just new up point. Let's go ahead and do the same thing. We will say object.freeze. We will pass in this, And by executing this code, we now have an immutable point object. So if we try to modify this once again, we're going to see an error on the right-hand side of the screen. So this becomes a problem if we want to inherit. So let's do class 3D point extends point, and then we will define our constructor with x, y, and z. We want to call super x and y, and then we want to say this.z equals z. And if we try to create a 3D point, then we are going to run into another error, because the whole idea of calling super is that it's calling the constructor on point. It's passing in x and y, and so all of this code is going to execute. But because we are dealing with actual types, we can get around this by checking the constructor that we are actually calling. So if we say this.constructor equals point, then we want to make this immutable. And so we will just call object.freeze and then pass in this. And then we will do essentially the same thing for our child class. So let's just copy and paste this code. So the idea is that we are creating an immutable object if the constructor that we are calling is the first constructor. So in the case of 3D point, if this constructor is equal to 3D point, then we want to freeze this object. And so now whenever we save this, we don't have any errors on the right-hand side of the screen, but we still have an immutable object. If we try to set a new value for z, we get an error. So creating immutable objects in JavaScript is of course possible, and it has been for quite some time. However, if you are going to use a creational pattern such as a factory or a constructor or a class, and you want to create immutable objects, you're going to have to think about how you want to go about that. If you don't plan on doing any type of inheritance or mutating an object in order to give it new functionality, then a factory function would work very well. However, if you do need some type of inheritance, then going with a constructor function or a class is a better solution. One of the more confusing aspects of JavaScript is how this works, because in JavaScript, this behaves differently than how we would expect it to. But with saying that, it's actually quite simple. The value of this is only determined when we execute the function. It's not determined when the JavaScript engine loads our code. It's not determined any other time except whenever the function executes. We're going to look at an example. Here we have a class called counter. We have a constructor that accepts an element object. We store that element object with a property called underscore element. We initialize a property called underscore count, and then we call a method called init. Init doesn't do anything yet. We will get to that in a few moments. But let's look at this increment method. Whenever we call the increment method, we are going to do several things. The first thing we will do is write the object that this refers to the console, just so that we can see what that object is. Then we are going to increment our count property. Then we are going to manipulate our element object by giving it some new content. So let's go ahead and run this. We'll say counter.increment. We'll call that. And over on the right-hand side of the screen, we see that our button content updated. And if we look in the console, we see that we have a counter object. We have a count property with the value of 1, and then we have an element property that contains our button element. So this code behaves exactly how we would expect it to. This, inside of the increment method, as I mentioned earlier, is only determined whenever we call this increment method. And this very literally means this object. Whatever context we call a function in, that is going to be what this refers to. So we are calling the increment method within the context of our counter object. Therefore, inside of the increment method, this refers to our counter object. And we can demonstrate this with another object. Let's create an object called empty. And this too is going to have a method called increment. But we aren't going to copy and paste our existing code that we have here. Instead, we are going to say that this empty object's increment method is going to be the same function that we have inside of counter.increment. So we are taking this function, we are assigning it to this property on our empty object. We'll say empty.increment, and we will see what results we get. The first thing we get is just an object inside the console. So this is what happens whenever line 17 executes within the context of this empty object. We see that instead of a counter object, we have just a regular object. And if we look at its properties, we have an underscore count property, but it is set to not a number. This is the reason why we have this. We are incrementing count here, but we could make this a little bit more clear by doing this. We'll say this dot underscore count plus 1. Within the context of this empty object, there is no such thing as an underscore count property. So whenever the increment method executes, we are creating that property here on line 18. We are setting that property equal to its current value, which is undefined, and we are attempting to add 1 to undefined. Well, that results in not a number. That's why we have not a number for underscore count. But notice that we don't have an underscore element. The reason being because we make no assignment statements for underscore element inside of increment. That is done inside of our constructor. So that's why we have the error here. It says that it cannot set property inner HTML of undefined. For our empty object, the underscore element property is undefined, and we can't very well set the inner HTML of undefined, so we get this error. This is where all of the confusion comes from. We are taking this increment method from this counter object, and we have seen that this works, and we quite logically think that this increment method is bound to this counter object, so that whenever we assign that method to something else, we expect to see the same results. But that's just not the case, because in JavaScript, this is evaluated only whenever the function executes. So whenever we call that function on the counter object, then this refers to that counter object. Whenever we call that same function on the empty object, then this refers to the empty object. Now, let's look at a case that always rears its ugly head, and that is whenever we are setting event listeners. So let's set up a click event listener on this button element so that whenever we click it, it should call this increment method. So let's just think that we are new to JavaScript and we're going to write this how we would expect it to work. So we're going to say this dot underscore element. We're going to call the add event listener method. We want to listen for the click event, and we want this dot increment to handle our click event. So we are assuming that we are going to take this increment method, it is going to execute within the context of this counter object, and everything is going to be fine. But whenever we click on the button, nope, it's not. And we can see why. Whenever line 17 executes, whenever we are writing this to the console, we can see that the value of this is the button element. And that is because whatever function that you use as a handler for an event listener is going to execute within the context of the element. The oldest way to get around this particular problem is to just use a closure, and it would look something like this. We would create a variable called that, and we would set that equal to this. And then for our handler function, we wouldn't use our method directly. Instead, we would use just an anonymous function, and inside of it, we would say that.increment. And whenever we save and click on the button, then we can see that everything works exactly as it should. Our object that we are seeing inside of the console is our counter object, and then the behavior works. We see the value of count increment. This is the old way of doing it, and there's nothing really wrong with this except that there's many developers that don't like creating a closure to set up an event listener. So we're going to count down. This is going to be the third way of doing that. Many years later, we finally have a method called bind, and we can use this method on any function object. And basically what it does is it binds a function to a particular object. It would look something like this. We would say this underscore element add event listener. We want the click event, and we would say this dot increment but then we would use that bind method, and we want to bind that method to this, so that the this keyword inside of the increment method is no longer evaluated at runtime. It is bound explicitly because we have told it to. And whenever we save and run this, we get the same results. The thing about this approach is that this actually creates a new function object. It's not changing our existing increment method in any way. It's going to create a new object where this refers to whatever we have passed to the bind method. Some people like that, some people don't. However, now that we have arrow functions, we can get away with much simpler code and really, quite frankly, better code. So once again, we're going to set underscore elements, add event listener. We want to listen for the click event, and here we are going to use an arrow function. And inside of this arrow function, we are going to say this dot increment. It is somewhat like the third approach, where we are creating a closure, except that we're not creating a closure. Instead, we are using this directly inside of our arrow function. Let's see this work, and then I will explain why this works. There we have verified that it works, and the reason why, because an arrow function does not have this. There is no this inside of an arrow function. Instead, the this of an arrow function comes from wherever we define that arrow function. So we have defined this arrow function inside of this init method. And this init method is executing within the context of this counter object. So therefore, anytime we use this inside of the arrow function, it's actually referring to the this found inside of the init method. So this is the same as this. Of course, the downside to this approach is that not every browser supports arrow functions. However, if you are fortunate enough to work within an environment where you don't really have to worry about that, then the arrow function is really the way to go. If you don't have the luxury of using an arrow function, then by all means, use the bind method. That's the next best approach. But if for some reason you can't use bind, and I really feel sorry for you, because that means you're dealing with IE 6 and 7, then you would want to use a closure. So remember that the this keyword is only evaluated when a function executes. The only exception is whenever you bind a function to a particular object. If you'll remember that, then you won't have any issues. There are a few patterns that have changed the way that we write and use JavaScript code, but none of them have had the impact of the module pattern. In fact, modules have had such a huge impact on the JavaScript community that we now have native module support in ES2015. In this video, we are going to look at the basic module pattern, because it is still useful, especially because native module support isn't fully supported across all browsers and environments. The first goal of a module is to limit the footprint of your code so that we have a single global variable, and then we access all of the things that we want to access through that variable. So basically, we end up with an object. So we are going to write a calculator module. And the first modules were simply object literals that had properties and methods that we would then use. So we would have an add method, we would have a subtract method, and any other properties and methods that we would want to use would be here within this object. This works, and for something this simple, this is really all that you need to do. But the problem with just using an object literal is that everything is publicly accessible. And so if you want to keep some things private and protected, then you need to use an immediately invoked function. In fact, this is the big reason why we use immediately invoked functions, is so that we can implement the basic module pattern. We are going to call this immediately invoked function. We're going to return an object that is then going to be stored inside of our calculator variable. And so anything that is returned is publicly available. Anything that is not returned, but it is still inside of the scope of this immediately invoked function, would be private. Let's create an array that's going to serve as our memory. Every time we perform some arithmetic operation, we are going to take the result and store it in our memory. So for add, we will say let result equal a plus b. We will push that result into our memory, and then we will simply return the result. And we will do the same thing for the subtract method. But of course, we want to change the plus sign to a minus sign. Let's add a property called store. This is going to be an option that will let anybody using this calculator module to turn on or off the ability to store the results in memory. Then that would look something like this. We would have this dot store, and then if that is true, of course, we're going to save the result in memory. Now I'm only going to implement this inside of the add method because this is going to lead us to an alternative form of the basic module pattern. Because the issue with this particular implementation is that all of the properties that we define inside of our object literal is only accessible from this object literal. We cannot use any of these properties inside of the quote unquote private part of our module. Now, before we continue, let me first of all say that there is nothing wrong with this implementation. There are many, many, many modules written just like this. And if this particular style of a basic module meets your needs, then by all means, go for it. However, this alternative form gives us a little bit more flexibility because what we end up doing is creating an object and then building that object piece by piece. So I've created an object called calc, and then I have created a property called store, and we will set that to true. And then we will create an add method for this calc object, and we will take the body of our existing add method and paste that in this new add method. And then we will essentially do the same thing for the subtract method as well. So that, yes, this requires a little bit more typing on our part, but as I mentioned, this gives us a little bit more flexibility. Because now anything that we define on this calc object is available inside our entire closure. And then at the end, we simply return calc. Instead of doing the check for the store property inside of our add and subtract methods, we're going to write a private function that is going to do that for us. So let's just call this store result. We will pass in our result and we will check to see if calc.store is true or a truthy value. And if it is, then we will of course push that result to our memory. And so that means that inside of our add and subtract methods, we have a little bit cleaner code. There's no if statements or anything like that. We are just simply calling our private function, and then the logic of that function is going to determine whether or not we actually store the result. But as far as the user is concerned, they don't see any of that. They still use the calculator object just like they did before. So we can add 1 and 2. We can say calculator.store is false, and then we could add 2 and 3 to get a different value. And now here's the trick. We need to be able to at least display the contents of memory for our test. Let's do this inside of store result so that it doesn't matter if we call add or subtract, it's going to do the same thing. So we will simply write to the console the contents of memory so that on the right hand side we see 3, which is what we would expect because that is the first operation that we perform. But then we turn the store to false. We run another operation, but we can see that the value of 5 is not added to our memory. Now, there's another reason why you should write your code using the module pattern, and that's because you can import other things into your module rather easily. All you have to do is have a parameter list for your immediately invoked function, and then pass in the objects or values for those parameters. If for some reason our calculator needed jQuery, we could call our parameter anything that we wanted. We could call it J, a $, whatever. And then whenever we invoke this function, we would pass in whatever you needed for that parameter. As you are writing your applications, I urge you to write your code using modules. Think about how you can break your code up into individual pieces and then write those pieces as modules. You can easily import modules into other modules by simply passing them as arguments to your immediately invoked functions. And that is going to give you more organized code, which by extension makes your code easier to maintain. And that is a win in any programmer's book. In this video, we are going to look at what is called the revealing module pattern. This is somewhat similar to the basic module pattern in that we have a global variable, we have an immediately invoked function where we return an object. So the end result is going to be the same as far as the user is concerned. But the difference is how we implement our code inside of the immediately invoked function. Now, what we have on screen is what I call the export variation of the basic module pattern. That is where we define an object, we build that object piece by piece, and then at the end, we export that object using the return statement. This gives us the flexibility of being able to access the properties and methods on our export object throughout our immediately invoked function. But it is rather tedious because anytime we want to access those members, we have to prefix it with the object name. Just like inside of store result, whenever we check the value of store, we have to say calc.store. In this example, it's not that big of a deal. However, imagine a very large code base with hundreds of lines of code for an individual module, and that export object could have a ton of properties and methods. That's just a lot of typing in order to access something on the export object. So with the revealing module pattern, we don't have an export object. In fact, the only object that we have is the object that we return at the end. Everything else is just a local variable or a local function to our immediately invoked function. So instead of calc.store, we simply just check the value of the store variable. So let's go ahead and create that variable and let's initialize that as true. And we will no longer have an add or a subtract method. Instead, we're just going to have functions called add and subtract. This gives us the ability to write just normal code using variables and functions. We don't have to use any object names. We don't have to use this or anything like that. Anything that we wanted to use within this module, we just use the variable or function name. So for example, if for some reason we wanted to call add inside of subtract, we could do that by just calling the add function. So what makes this the revealing module pattern is how we reveal the things that we want to be made public. And that is by simply using the pointers to our function. So we are going to reveal the add method, and we are going to reveal the subtract method. And we could use the shorthand syntax. Let's do that. We'll say add and subtract. If we wanted to reveal the store result, we could do that, but we don't want to because that needs to be private. And that is essentially the reveal pattern. But what about the store variable? Now, this is a variable. We can't just come up here and say store because that's going to refer to the property on our return object as opposed to our store variable. The solution is rather simple. We just have a getter and a setter. So we will say get store and we will simply return store. Once again, we don't have to use this or anything like that. We'll just use the local variables and functions. And for the setter, we will have our value and we will simply say store equals value. And so we have our module. And of course, we can guarantee that this works by just checking to see the output on the right-hand side. Although now we have an uncaught reference error. Subtract is not defined. Let's see, that's on line 39. That's right there. And that's because I mistyped subtract. With that change, we see the results that we would expect. If we don't change the value of store, then we see that the value of 5 is added to our memory. So we have the same result, but we have, at least in my opinion, easier to maintain code. In this video, we are going to examine native modules. Now, let me first of all say that at the time of this recording, there are no browsers that support native modules. The exception is Microsoft Edge, but it is hidden behind the experimental JavaScript features. So if you have Edge and you want to use Edge to execute the code from this video, you will want to go to About Flags and then scroll down to where you find the JavaScript section and then enable experimental JavaScript features. You will need to restart Edge, but once you do, you can use modules. Now, if you don't have Edge or you don't want to use Edge, there is an alternative. You can use a transpiler. And Babel is the de facto standard when it comes to transpiling ES2015 code into just normal JavaScript code. In fact, this is being used in production. Many developers are using this to transform their ES2015 code into code that will execute in both the browser as well as the server. So this is a very stable solution, and there's no reason why you couldn't use it. We aren't going to go through the setup. You can go through that yourself, but once you do, you will be able to use modules as well. Here on screen, we have a module using the revealing module pattern, and we are going to convert this into just a native module, and then we're going to modify it some. And the first thing we are going to do is get rid of our immediately invoked function because we don't need it anymore. All of the code that we are writing inside of this module is not going to impact the global scope. We don't need an immediately invoked function, which is nice because while that's such a small thing, not having to do it is also something very nice as well. We will get rid of that. That also means that we don't need this return statement anymore. Instead, we are going to create our calculator object here. And we're going to, first of all, get the same result as we would have with the revealing module pattern by simply exporting our calculator. And to do that, we just say export and then calculator, and that's it. We are going to use this calculator object inside of app.js. And the first thing we need to do is import calculator. Now, the really nice thing about this is whenever we import something, it is a constant. We cannot override it. So this is protected, and that's very nice. But we also need to specify where this calculator comes from, and that is inside of module.js. So we have now imported our calculator. We can use the calculator object, and whenever I save this on the right-hand side of the screen, we will see the results. We see two lines that were written to the console. And the first one is due to calling the add method on our calculator. If we look at the module, there's a function called store result, where whenever we add or subtract something, we attempt to store that result in memory. Now, there is an option called store, and if we set store to false, then the result will not be written into the memory, and that's why we see two lines written to the console, but the second line is not updated with any new results because we told it not to store that. So we have the same result that we would have with the revealing module pattern, except that we have written this code using the native import and export keywords. Because we don't really have to worry about the impact on the global scope, we don't really need to hide our functionality inside of an object. I'm not saying that we don't need an object all of the time, but in this particular case, we don't. Because really all that somebody is interested in as far as a calculator is concerned is performing the arithmetic operations. So we don't need to export calculator. Instead, we can export the add and subtract functions. And you will see this pattern being used in production by a variety of module developers. They are no longer exporting a single object. Instead, they are exporting the functions that we want to use. So inside of app.js, we don't have the calculator anymore. Instead, we have the add and subtract functions. But in the case of this file, we're only using add. So add is really the only function that we need to bring in. And so we can call the add function twice. And over on the right-hand side of the screen, we still see the two lines of output, but now we see where our memory has two results, 3 and 5. Fortunately, we have lost the ability to change the value of store because we could export store if we wanted to, but it is going to be a constant. Anything that you import is a constant. So if we bring in store and if we try to assign a value to store, we get an error. We cannot assign a value to a constant. So if we wanted to enable this ability for the user to turn off the storing of the results, we would need to write a function that would change that value. So we could say function set store, we could accept a value, and then store equals value. And then instead of exporting store, we would export the set store function. And then we would use that inside of app.js. So now we can say set store, we will pass in false, and then we will see the results that we had before, where two lines are written, but they both contain the same results. So when it comes to modules, the native module support in ES2015 is superior to the modules that we have been using for the past few years. And if you are developing an application within an environment where you can use Babel or some other transpiler, then there's really no reason not to use native modules. For one, it future-proofs your code. You get the benefits of a module, as well as superior features to the basic and revealing module patterns. One of the prevailing concepts in client-side development is the idea of separating or decoupling your JavaScript and markup. And it used to be a pretty clear rule to follow, but today, well, not so much, because we now have a very popular framework called React. And it completely defies this rule of separating your code and markup. Now, if you're not familiar with React, this is what it looks like. We have some JavaScript code. You can see class, shopping list, extends, React.component. There's this render method that returns, oh, hello, we have markup. And it's not markup contained within a string. This is actual markup. Now, this is XML, and this works because of the XML extensions to JavaScript. But there is a clear, tight coupling between our code and markup. And really, this is just an evolution of what we saw with jQuery plugins. There were many plugins that would create HTML element objects using the jQuery function by passing HTML to that function. But in my opinion, this is a much better approach. The idea of separating markup and code can still be followed. We just have to define what is and isn't acceptable. So with React, we are including markup inside of our JavaScript code, and that is now obviously acceptable. However, including JavaScript code inside of our markup can still be considered a bad practice. And so in this video, we will examine techniques that allows us to add code to our pages unobtrusively. The first, and really the only thing that we want to avoid, is directly embedding JavaScript in our HTML. There are many ways that we can go about embedding code, and the first is just with a simple script element like you see here. This contains JavaScript code, therefore this is embedded within our HTML, and we really don't want to do this. We want to put this inside of an external file, and there's several benefits to doing so. First of all, an external file can be cached by the browser, so any subsequent requests can then just be loaded from cache, and that saves time for the user. Second, it allows us to organize our code into individual pieces, and it really works well if we use some type of module pattern for our external files. But if everything is broken out into their individual files, that means it makes it easier for us to find what we want to work on and then work on it. And that also helps us with debugging. If all of our files are in external files and we need to debug certain pieces of our code, it's just easier to do that than if our code was embedded within the HTML page itself. So I've taken the code that was inside of the HTML file and I've put it inside of an external file, but I'm going to turn this into just a very simple module. In fact, we're going to use the basic module pattern here just to save a little bit of time. We are going to wrap the majority of this code with an immediately invoked function so that we can protect the things that we want to protect while also exposing the things that we want to expose. So as far as protection is concerned, we really can protect our element object. We don't need to reference this within this return object for our calculator. So let's do this. We'll say we'll call this element. Let's just copy this code, and there we have our element object. We of course need to change the reference to this so that instead of this an underscore L, we just say element. And that is going to make this code a little bit better. Let me first of all say that this is not the best code, especially because we are taking the contents of an element and then we are evaling it. And that is definitely not something that you would want to do in a production application. It might be great for prototyping. That's definitely not something that you want in production. But I did it here because it was very simple to do, and we're not focusing on that aspect of it. We are using the basic module pattern. We are protecting our element object that refers to the results, which is this little box up here. And we have two methods, button press and eval. We've improved our little application a little bit. Let's look at the next way that we can embed JavaScript in our HTML, and that is with the DOM level 0 event handlers. This is less than desirable for a variety of reasons, and I make that sound like it's not that bad of a thing, but really this is a very bad thing to do. Because any change that we make inside of the actual JavaScript code, we might have to come to our HTML and make a lot of changes. Like if we change the name of calculator or button press, or if we change the signature of the button press method, then we have to come to our HTML. We have to make all of those changes and hopefully we won't miss something. But if you're like me, chances are you're going to miss something, and that's going to take even more time. This is not something you want to do, because anytime you change your JavaScript, you run the risk of breaking the rest of your application. Instead of having the onClick event handler here, what we can do is assign all of this stuff inside of JavaScript. We are programmers after all. We can easily find the elements that we want to manipulate and manipulate them. Let's get rid of these, and then let's talk about how we can select these elements. These are button elements. They have a class of the column classes with Bootstrap. So that's not really something that we can use, but we can use data attributes. And in this case, it would be a nice thing to do because we could have a data-value attribute. And ideally, it would be named something else like calculator value or something like that. But this way, we can specify the value of that particular button. And then that would give us a way to set up the event listeners through JavaScript so that whenever we changed our JavaScript code, it's not going to break our application due to anything that we have in the HTML. Let's look at what that could look like. Now, what I'm going to do is just use event delegation. We're going to set up a click event listener on the document, and then we are going to filter out everything except for these button elements. So we want to listen for click. We have our event listener here. And the first thing we want to do is get the event target. So let's say targets.e.target. And then we can check to see if target matches our selectors. So we have a button that has an attribute of data-value. Actually, let's do this. If it doesn't match that, then we are simply going to return. So that's going to filter out everything that is not one of these button elements. Otherwise, we want to call the button press method. That is part of this return object, so what we could do is use the revealing module pattern so that we have a function called button press. Let's go ahead and define that. And I guess we will do the same thing for eval just for the sake of completeness. But that way we have a reference to those functions so that inside of this event listener, we can say button press. We will get target, get attribute, and we want data-value. So let's very quickly copy and paste the code for eval. We will make that a function up here, change the syntax. We will change our return object to just return button press. And eval will use the new hotness that comes with ES2015 so that we just have to say button press and eval, and this should work. If we come over to the browser and we click on 1, 2, plus 4, 5, now the equal sign really isn't set up, but we could do that inside of button press. If value equals the equal sign, then we are going to eval. And I just noticed that this is not going to work eval result, then we should be good to go. So let's do 1, 2 plus 2, 3 equals 35. That's great. We don't have a way to clear. I guess we could refresh. And then 7 plus 8 equals 15. So now all of our JavaScript code is within our JavaScript. We can make our changes here, and it's not going to affect anything that we have in our HTML. Now, of course, if we modify our HTML, well, then we're going to run into some issues, but we would anyway. So that's not that big of a deal. While it is acceptable now to incorporate markup within our JavaScript, it is still a very good idea to keep our JavaScript outside of our markup. It saves time for the user, and it saves time for you too. Web development naturally fits into the idea of separating concerns because we work with very distinct languages that are responsible for different concerns. We have HTML, which is responsible for structuring and organizing our content. Then we have CSS that determines how our content looks. And then finally, we have JavaScript, and that defines how the user interacts with our content. There's this natural separation between these technologies, but we can easily couple them together, and when we do so, we typically worsen our code. When it comes to CSS and JavaScript, there's really just two things that you need to watch for. The first is performing multiple individual style changes on an element or its children. We have a div element with a class of content box, and it has just some simple content in it, so there's not much complexity going on here. Well, let's say that whenever we double click on these content boxes, we want to change the foreground color to yellow and the background color to blue. I have some CSS already set up here. It sets the height and the width, it also sets the background color, and it also sets the margin just so that it positions it in the center horizontally. We'll come back to this, but let's go to our JavaScript. This is interaction. The user double clicks on an element, so we are going to change the way that it looks. And so I've gone ahead and set up a double click event listener on the document so that we can use event delegation. That means that we need to filter out all of the elements that don't have a class of content box. So let's create a variable called target that is going to be set to e.target. And if not target matches, and then our selector, which is going to be content box, then we are just going to return. Otherwise, we want to change the style of this element. So we're going to do that with the style object. We'll say color equals to yellow, and then the background color is going to be blue. And of course, ideally, we would toggle this so that the first time that we double clicked on the element, then we would change these colors to yellow and blue. Whenever we double clicked on it again, then it would change it back to what it was before. We're not going to write that logic. Instead, we're just going to change the color. So as I double click the element, you can see that it changes. Now, this is not ideal because we are making individual changes to the style. Whenever you do that, you are forcing the browser to redraw that element. So here we have two lines of code where we update an element's style, and in doing so, we are causing the browser to update that element 2 times. That's not very efficient. Let me also say that if you're using jQuery, then you're probably doing something like this. You'll have your target, and then you're calling the CSS method, passing in an object where you set color to yellow, and then the background color to blue. And you're doing the same thing here because what jQuery does behind the scenes is it takes this object, it iterates over the keys, and then it sets the individual style properties. So you're not gaining anything there. Instead, it is much more efficient to make a single large change to the document than it is to make multiple small changes. We can do that very easily by just adding a class to the element. So let's go to our CSS and let's say that this is going to have content box and double click. And it would probably be named something else like just double click. In fact, let's do that because that's a little bit easier. But here we can say color is going to be yellow, and then background color is going to be blue. And then inside of our JavaScript code, we are going to just set the class list. Instead of changing the style individually, we will say target class list. We're going to add in that double click class, and we're going to get the same results. But the great thing here is that we can add in the ability to toggle that class, and we don't have to add any other logic. If the class is applied to the element, then it's going to remove it. Otherwise, it's going to add it. Even though in this case, we're just making two minor changes, it is still more efficient to do this with a class. So anytime that you need to change multiple style properties on an element or affect the style within an element's children, organize that style information as classes, put those classes in your style sheets, and then reference those classes in your JavaScript. The second thing that you need to be mindful of is using CSS classes as hooks for your JavaScript code, and more specifically, using CSS classes that are being used to apply style to elements within your JavaScript code. Like, for example, we have essentially a hook here for content boxes. And you know what? Let's change this so that this is going to be a true check. So if the target matches content box, then we are going to toggle the double click class. That way, if we had some other selector that we wanted to check for, if target matches, let's say icon, then we would do something else here. So this content box class is being used in CSS to apply style. The reason why we don't want to use this type of class as a hook for our JavaScript is because these classes can change. What if we or whoever is designing the UI decides, okay, this shouldn't be called a content box. It should be called something else. Let's say that this is an alert box. They change the markup, they change the CSS. And while this is going to make it look like it did before, it's not going to behave the way it did because our code is essentially broken now. So instead of using CSS classes that apply style as hooks, we can either create our own CSS classes for hooks like JS, and then double click. And then we could use this class for anything that we wanted to handle the double click event on. Or we could use data attributes. There's really no best practice as far as this is concerned, except to not use a class that is used to apply style. But if you do use a special CSS class, use something in the name to denote that this is for JavaScript. That way you don't end up using that class for style. So in this case, we're going to use a class called JS double click. And then inside of our code, we will use that class as our hook so that now we can change whatever class that we want to this element as far as styling is concerned, and our code is going to still work. So when it comes to writing JavaScript for your CSS, you want to apply styles using classes. Remember that it is more efficient to make a single large change than multiple small changes. And don't use CSS classes that are used to apply style as a hook for your JavaScript. Either use data attributes or use your own custom CSS classes. But whatever you do, be consistent. The DOM is one of the slowest components in client-side development. Anything you do with the DOM is going to slow down your application. Now, I use the term slow loosely because really it depends upon what you are doing that determines how slow your application becomes. Doing simple things like finding elements or making a few very minor changes to the document will execute slower than pure JavaScript, but it's not going to slow your application down to the point that the user actually sees the slowness. However, if you make multiple large amounts of changes to the document, well, that can cause some visible stuttering, and the user will see it, and that's definitely not something that we want. So the general rule of thumb is to avoid the DOM as much as possible. And we're going to look at some techniques in this video to allow us to do that. So we're going to start with something easy, such as retrieving elements from the document. So we have a div element with a class of content box. And let's say that we want to get this element so that we can work with it at a later time. In this case, we would use the query selector method and then our CSS selector, that is content box, and there we have retrieved that element. I like to think of the DOM as a swimming pool and the elements as coins within the swimming pool. Well, if you want to get one of those coins, you have to dive into the pool to get it. Now, if all you need to do is just look at a single coin just one time, then doing something like this is perfectly fine. Document.query selector, and then if we wanted to modify the class list of this element, then we could do that. However, the majority of the time, we want to retrieve a coin and reuse that coin whenever we need to reuse that coin. To translate that into actual JavaScript code, we want to dive into the document, we want to query it using our CSS selector, and we want to store that within a variable, because it doesn't make sense to keep diving into the document for the same coin over and over and over again. So create a variable and store that element within that variable. The next thing is creating elements. We're going to recreate this content box. Actually, we're going to create a new content box and then add that to the document. And anytime that you create new elements, you want to do so from outside of the document. Because if you create an element and then add that to the document and then modify that element, you're causing the browser to reflow the page. And that is an expensive process. It has to recalculate not only the element that you're adding, but all of the other elements, because the element that you're adding could cause some changes as far as dimensions or things like that for other elements. The best thing to do is to create your elements, modify whatever you need to do, and then add those elements to the document. So let's create an element called div, and we're going to use the create element method, and that is of course going to be a div element. Now we don't want to immediately say document body append child div, but we will eventually do that. So let's go ahead and leave that code there. But instead, we want to build up this div element. One of those things is setting its class. We could do that with class name, or we could use the class list, or whatever we wanted to use. In this case, class name is simple enough to use, so we're just going to say that this is a content box. And then we're going to cheat and use inner HTML. We're going to have an H2 element that says heading, and then let's have a paragraph that says this is new content. If we wanted to be absolutely correct, then we could create those elements using the DOM API, append them to our div element, and then finally append that to our div or to our body. We have created a div element, we modified it before we added it to the document, and then we finally added it to the document. But let's say that we wanted to add two of these content boxes so that we essentially do the same thing. That means that we create another div element, we set its class name, we set its inner HTML, and then we append that to the body. In this particular case, it's not going to be that big of a deal, but if we are creating a rather complex element that has quite a few children, and especially if we need to create many more of these types of elements, we don't want to do this individually. Instead, we want to use a document fragment and use that as a container for all of our new elements so that then we can just append that document fragment to our document, and there's just one write being done to the DOM as opposed to multiple writes being done. Let's create a function. We're going to call this create elements. And the only reason why I'm doing this is just so that we can segment this out into its own little bit of scope. So instead of writing these div elements directly to the document, we're going to create a document fragment. And we'll do that with create document fragment. And then we will append these div elements to this document fragment so that finally, all we have to do is then say document body append child and then frag. So that now all of our creation and modification is done outside of the document. And then finally, all we have to do is add that fragment to the body. That takes one write, and then we are good to go. When it comes to creating elements, that is the best way of doing that. However, what if we wanted to work with elements that are already within the document? Well, this is a little bit more involved, because we want to take the same idea as far as creating elements. We want to work with our elements outside of the document. So that means that we essentially have to remove the element that we want to work with, make our modifications, and then add it back in. But we want to add it back in where it was to begin with. So that means that we need to not only know the parent node of the element, but also its sibling. So we can write a function, and this is going to be a simple version of this function. But we could call this detach. The idea being that we are going to detach an element, and then we can pass in a function that we would then execute to perform our work on this element. The first thing we need is the parent node. So we can say parent, that is element, and then parent node. We also need the next sibling. So let's just call this sibling, and we will use the next sibling property. And then we want to remove the element that we want to work with. So we'll use our parent node, we'll call the remove child method, and we will remove that element. And then once we have removed that element, it is offline. It's not within our document, so we can now work with it. So we can call our function, and we could do a variety of different things. We could call the function, pass in the element as an argument, or we can use the call method, and we could execute this function within the context of our element. And then we will simply add that element back in. But in this case, we want to insert it exactly where it was before. So we'll say insert before. We want to insert this element, and we want to insert it before the sibling. Now we are going to take our box element that we retrieved earlier, and we are going to add more paragraphs to it. We can say detach. We're going to work with the box element. Our function is going to create, let's just say 10 new paragraphs. So I'm going to use a for loop to do that. We will increment as long as our increment variable is less than 10, and then we will actually increment that. Let's create our p element with document create element, and this is going to be p. Let's set the inner HTML to be something generic, like this is paragraph, and then we could use our counter variable. We will then append this new paragraph to our element. So we can say this append child and then pass in p. And that should be all that we need to do here. So now all we need to do is just save, and we can see on the right-hand side of our screen, we updated our existing content with some new content. When it comes to working with the DOM, you want to limit your interaction as much as possible. If you are retrieving elements that you will repeatedly use throughout your application, store those elements in variables so that you don't have to keep diving into the DOM to find them. If you are creating new elements, create them outside of the document and do whatever you need to do to those elements before you add them to the document. Limit the amount of times you add new elements to the document. If you can do everything with one append, then do it with one append. And if you want to modify existing elements, you want to detach those elements from the document so that you can modify them offline and then insert them back to where they were. JavaScript development has drastically changed over the years. We started with very simple text editors, and you could forget about the sophisticated developer tools that can be found in today's modern browsers. But despite all of that, JavaScript became the most popular programming language in the world. And as a consequence, we now have some very rich tools that make developing for the browser and server much easier. One of these tools is Node Package Manager, and it is the lifeblood of modern web development. If you're not using Node Package Manager, then you're missing out on a ton of tools that can help you write better code and save you a lot of time. If you use NPM, then I regret to say that you probably won't get much out of this video. But if it's new to you, or you've looked at it and thought that you'd come back and check it out later, well, now is the time to do so. This is the video for you. First things first, Node is a JavaScript runtime environment that can run both web and desktop applications. So yes, that means that you can write a web application or a desktop application with JavaScript. That is what Node is for. And so, in order to supply developers with libraries, frameworks, and utilities that they can use to write their applications, the people behind Node created a system that can house and deliver those assets. Now, we call those assets packages, and the tool used for creating, storing, and retrieving those packages is called Node Package Manager, or NPM. Now, in order to use NPM, you need to install Node. So if you don't have Node on your system, you want to go to nodejs.org, and it's going to default to your operating system. Now you're going to be given two choices. You have what's called the LTS, that stands for long-term support, and then there's the current version. Now the long-term support means just that. It's going to be supported for a long time. So it is going to be maintained. There are going to be updates to it, but it's not going to really change. So you don't have to really worry about any breaking changes or anything like that. Only even numbered versions of Node are going to be LTS. So version 6 was the last even version number for Node at the time of this recording. So this is the last LTS version that we have. The current version is version 7.5. 7 is, of course, odd. So there's not going to be any long-term support for version 7. That's going to be done for version 8. But either way, you will get Node, and more importantly, you will get Node Package Manager. Now, I typically opt for the long-term support because I want a stable environment, so feel free to download that. The installation is very simple. You just download the installer, run the installer, take all of the defaults, and you will be good to go. Now, there is an option for installing NPM, and it is enabled by default, but make sure that it is checked, because that is the whole point of getting Node, at least in our case. So after you have Node and NPM installed, you will want to go to the command line because NPM is a command line tool, and all of the NPM commands begin with NPM. So the first thing we want to do is create a project, and we do so by essentially creating a folder. So let's make a new directory. We'll just call this first NPM. Then we will cd into first NPM, and then we're going to run a command called npm init. Now, I've called this a project, but what we are also doing is essentially creating a Node package. If this is something that we wanted to actually share with other people, we could create our package, we could write the code that we wanted to write, and then we could put that in the registry if we want to. Now, we're not going to do that in this video, but we're going to walk through the process of creating what's called a package.json file. It is a configuration file for our package. And so that is what npm init does. It is initializing a new package. But we want to do this because we want to use npm to manage our dependencies. So that if you wanted to use jQuery or Angular or React or anything else, you can use npm to retrieve those things for you. You can also use npm to run commands to perform certain tasks, like running ESLINT on your code or running a minifier to minify all of your code. There's a lot of things that you can do with npm that will make your life easier. If you run npm init, it's going to walk you through several questions, and these are just the initial things needed to set up your package. So the first thing is the name of the package, and it defaults to the name of the directory that you're running the init command in. So here we can see that it is first npm. If you wanted to name it something else, you could do that here, but we're going to take the default. The version defaults as 1.0. Let's set it at 0.1.0. And then the description. This is a test package, and you can put whatever description that you wanted to there. The entry point. This is for Node applications. So a Node application could also be considered a Node package. And this would be the entry point for our application if that is what we were going to be writing. We're just going to take the default here. If we wanted to specify some other JavaScript file as the entry point, we could do that. The test command is a command that we could use to test our code. So we would run the test command, it would go through and run all of our tests, and then we would be good to go. We can also create our own commands so that we can issue some other tasks to perform. And then the Git repository. This isn't going to go out and look at that repository or anything like that. That's just for documentational purposes. So you could put in a Git repository there. Any keywords for this package, you could specify there. The author, let's put my name, you can put yours. And then the license, you can specify the license that this package is going to be licensed with. The default is ISC. And then finally, it's going to ask, is this okay? And the default is yes. So let's take that. Now, if we look at the contents of this directory, we now have a package.json file. This is essentially everything that we see here. So if we view this file inside of our code editor or anything else, we're going to see the same contents within that file. We see that JSON there, and we can come in here and manually edit this with our own configuration, or we can use NPM to do that. Well, let's say that our application is going to use jQuery. We can install jQuery like this. We can say npm install jQuery, and then that is going to install jQuery for our application. But we can also come in here and we can say that we want to save this. This is cool because as we run this, let's go back and look at our code here. We will eventually see this dependencies being added here. What we can do is we can take this package.json file, and then we can put this in any other folder that we wanted to. We can go to the command line and then type in npm install, and it's going to look at those dependencies, and it's going to install all of those dependencies automatically. Once it's listed here, we don't have to reinstall that if we ever wanted to start from scratch again or anything like that. We could just run npm install. It will install all of the dependencies, and then we will be good to go. Now you can also see that there's now this node_modules folder. This is where all of our packages are going to be installed. Here is jQuery, and there's the dist folder that has the jQuery code that we could reference within our application. Or if we wanted to use anything from the source, that's there as well. So there are a lot of packages to choose from. And if you wanted to go to the website, you can just Google NPM. There's a website, npmjs.com, that is the NPM registry. So if you wanted to search and find packages to use within your application, you could do that. So if we wanted to use React, you can see it lists some packages here. This isn't React directly, but it is a toolkit. It tells you how to get that package. And some of the pages also have some information about the package and how to use the things within that package. If you haven't already, go get Node, install it. You want NPM. It will help make your life so much easier. It doesn't matter what programming language you use, you need to lint your code. Now, if you're not familiar with the term lint or linting, it's really nothing more than running a program to analyze your code. A linting tool is going to look for common mistakes and even not so common mistakes. These things that could lead to other problems or bugs within your code. It's then going to either alert you to those problems or it's going to fix them automatically. And it will also enforce some kind of styling so that your code is consistent. It doesn't matter if you write for the browser or for Node or for some other JavaScript environment, you need to lint your code. Now, we have several choices as far as linting tools are concerned, but ESLint is becoming the de facto standard. Not only is it pluggable, meaning that you can plug in things to ESLint, but it can be used as a plugin for your code editor. If you had a code editor that had plugins, you could install an ESLint plugin and you could have linting built into your code editor. And while that's nice, it's also nice to have it as a standalone tool because then you can make it part of your build process. And everyone who works on your project can then use ESLint and use the same settings, which is important because you don't want a bunch of different people using different settings as far as lint is concerned because it could change your code. What we are going to do in this video is get started with ESLint. We are going to create a new package or a new project. So let's go ahead and do that. Let's make a directory and I'm going to call this ESLint test. And then we want to cd into that directory and then we're going to initialize this project. Now, if you wanted to answer all of the questions one by one, then you could just do npm init. But if you wanted to skip all of that, you could say -- yes, or dash dash force. Either way, it's going to create our package.json file, and it's going to answer all of the questions with the default values. And while we're here, let's go ahead and install ESLINT. So we're going to say npm install ESLINT, and we're going to save this to our project so that whenever we wanted to put this into source control, then all we would have to do is just say npm install, and then it would install ESLint as well. And this just takes a few seconds. It might take 15 to 30 seconds based upon your machine speed and your network speed because it has to download and extract all of that stuff. But once it's done, then all you need to do is initialize ESLint. And we do that by saying node underscore modules, and then we want the bin folder, then ESLint, and then init. And this is going to walk us through some questions. The first thing is the style of our code. Now we can use a popular style guide if we wanted to, or we could let ESLint inspect our JavaScript files and build a style configuration based upon that. Let's just go with the popular style guide because there's three that it's going to give us by default. The first is Google, the second is Airbnb, and the third is standard. Well, let's start with standard. And then it's going to ask, okay, how do we want to store the config file? We can have JavaScript, YAML, or YAML, or JSON. Let's go with JSON because I like JSON. And this is going to install all of the necessary plugins for ESLint so that then it will use the standard style guide as well the style guide. Let's go ahead and start up our code editor, and we want a JavaScript file that we want to test with. So let's create a new file. I'm just going to call this test.js, and we don't really need a whole lot of code. Of course, in a real project, we are going to have a ton of code, but in this case, let's just have a single line. We'll call it hello world, and then let's assign it a string value that says hello world. Very simple. Let's go back to the command line, and now all we need to do is run the ESLint command. Node modules, basically what we did for init, so we could just use that, and then we could specify the file that we wanted to lint, test.js in this case, and this is going to run the linting tool on test.js. And we can see several errors based upon that standard style guide. There's a missing space before the function parentheses. There is an expected indentation of 2 spaces, but it found 4. And, there's several other things here. So let's do this. Let's take this code that we have and let's copy it. And let's run this again. But now we're going to say that we want you to go ahead and fix most of these common things. So we're just going to say dash dash fix. That is then going to fix all of those problems. You can see that most of them are gone. But now there's just one, that the variable hello world is assigned, but it is never used. Let's go and look at our code. You can see that it has changed. Let's compare that to what we had originally written. The indentation is different. The quotes are now single quotes as opposed to double quotes, and the semicolon is missing as well. And this style guide, as well as the rules, were based upon that standard style guide. So let's copy all of these things. And let's modify our configuration. Let's say that we want to ensure that we always have semicolons. So we want to go to this eslint.rc.json file, and this is the configuration for our ESLint. Now you can see that it extends the standard style. So there's a lot of things that are just hidden from us. But we can come in here and we can specify our own rules. And one of those is going to be the semi rule. Basically, we want to say that it is always going to be an error if a semicolon is missing. We want to save this. Let's go ahead and save this JavaScript file as well. And we are going to run our command again. Now we still have that same error. Hello world is assigned, but it is never used. Notice that we have a semicolon. And just to compare that with the previous code, the indentation is now the same, but we of course now have semicolons, and that's what we like. There are a variety of rules that you can add to your configuration, and if you wanted to find what those rules are, the ESLint documentation is where you want to go. We can run this command on any file that we want, but a lot of times we want to run this on all of our files, which we can very easily do. We could just say star.js, and it's going to run on all of those JavaScript files. But it would be nice if we could take this command and make it easier to type. Let's copy this, and we are going to add this to our package.json file. Inside of our scripts here, we have this test script, but we can also come in here and we can say that we want a script called ESLINT. We want to call that same command. So we'll say node modules.bin and then ESLINT. And then in this case, we want to run on all of the JavaScript files. We want to fix them. But there's another option that we could use too. We could say that we want to cache them so that ESLint will ignore all of the files that have not been modified since the last time that it was run. This way, this could speed up ESLint if we have a project with a lot of JavaScript files. Now we can go back to the command line, and instead of running this command, we can say npm run ESLint. ESLint is the name of the script that we just created. Let me make sure that that is saved. It is. And then we can run that, and it's going to run the same thing. We are going to see this particular error here. The reason why is because ESLint ends with a status of 1. If there are errors that are found within a file, then it ends with a status of 1, and thus we get all of these NPM errors. But we can ignore these. The main thing we want to focus on are the errors from ESLint itself. And once again, we are getting the same error that hello world is assigned, but it is never used. So let's change that. Let's say that we are going to write that value to the console. So we will just call console log. We will pass in hello world. And let's leave off the semicolon so that whenever we run our ESLint command again, it is going to automatically add that semicolon. You can see that now the errors are gone as far as the NPM errors are concerned because ESLint exited with a status of 0. So NPM thinks that everything is now fine. And so if we look at the code, we now have that semicolon that we left off, but the rest of our code has been fine. It's been verified by ESLint. Therefore, we are good to go. As websites evolve into web applications, they rely more and more upon JavaScript. And that means that we have more and more JavaScript files, and it can become a rather tedious thing to work with all of these files, especially whenever we want to deploy our application. Now, there are many tools available that can make our lives a little bit easier as far as this is concerned. But one of those is Webpack. And I'm not going to say that this is the de facto standard, but this is the tool that JavaScript developers are starting to move to because, we get new tools on a weekly, almost daily basis. And while Webpack has been around for 2 versions, and it will be around for many more, that doesn't mean that there aren't going to be newer tools that do this better. But as of right now, Webpack is really our go-to tool for a variety of reasons, but one of those is to hot patch modules. Basically, we can write our code as modules. It's going to bundle all of those modules together so that we have just a few static assets. And if we need to hot patch those, that means that as our code is running within a JavaScript environment, we can hot patch a module and it's going to load that module as the application is running. That's true for the browser as well as the server. It's really a fantastic tool. Let's take a brief look at the application that we will be working with. And I say application very loosely here because this is very simple. Basically, we have 2 files. We have a file called calculator.js. You can see that we are using ES2015 module syntax here. It simply defines a calculator that has a sum method. And then the main JS file is importing that calculator module. It creates a new calculator, and then it uses the sum method to display a result within the console. Let's look at our packages that I have loaded here. We have ESLint so that we can ensure that our code is going to be up to snuff. There's also this HTTP server module. This is an HTTP server so that we can run our application and see it working within the browser. I've set up an HTTP script so that it will use the HTTP server using the public folder as the root. So basically, inside of this public folder in the root of our application, that's going to be where the website's going to run from. The code inside of the source folder is not going to be available outside of that. Webpack is going to take those files and then bundle them together so that we can use that inside of our public folder. Let's add Webpack to this project. So in the console, we say npm install Webpack. We could install it globally if we wanted to, and some developers like that. Other developers like to just save that to the project so that you don't install anything globally. We'll take the latter and just save that. And Webpack requires a config file because everything else requires one. So let's create a new file. We're going to put this in the root of our project, and we're going to call this webpack.config.js. Now, whenever you run the Webpack command, you can specify a config file, but if you don't, then it's going to default to this Webpack config. Here we need to write some JavaScript code. This is not a JSON file, so the first thing we want to do is require Webpack, and then we also want to bring in the path because we want to specify where we want to put our bundled JavaScript code to. So we're going to require path as well. And we are using the Node style of module syntax. We're not using ES2015 modules here. And so we are going to export a couple of properties. The first is called entry. Webpack needs to know the entry point of our application because it's going to look at that file and then it's going to find all of its dependencies and bundle everything together. It's also going to load all of the dependencies for our dependencies. So in our case, our entry point is the main file, main.js inside of source and public. So it's going to see that it uses the calculator module, so it's going to load that and bundle that all together. So the entry point is a source, public, and then a main. But the second thing it needs is the output information. And there are two pieces here. The first is the path that we want to use as our output location, and then the file name. Let's start with path. Well, we have our public folder. That is where we want to output our bundled code. So we're going to use path.join. We are going to join the directory name with public. And then we also want the file name, which is simply called file name. And in this case, let's just call this app.js. So we are going to bundle everything into app.js. That's going to be put inside of the public folder, inside of the root, so that inside of index.html, we will need to add a reference to our JavaScript file. So let's just add a script element. We need a source attribute for app.js. This, of course, doesn't exist yet, but once we run the Webpack command, it will. Now let's go to the package.json file and let's add a new script. And we could just call this Webpack, and then we could just call the Webpack command. Let's do something a bit more complicated. We want to ensure that we have good code, and we have ESLINT, so let's go ahead and use ESLINT. So let's create a script that's going to run ESLINT, and then if everything is okay there, it's going to run Webpack. Let's call the script build client. We would use this to build the client side code, and we want to run ESLint. We want to specify the files that we want to lint, and then those are inside of source public, and we want all of the JavaScript files there. Let's tell it to go ahead and fix all of the issues that it can fix. Let's also cache everything. Now I'm using just the standard style for ESLint. There are no custom rules. I just took the defaults there. So this is going to run ESLint and all of that, but then we need a logical and operator, and then we start the Webpack command. And in this case, we're just running Webpack, but if we wanted to specify the config file, we could say config, and then whatever that config file is. So it's going to run ESLint, and then it's going to run Webpack if ESLint succeeds. So we will say npm run build client, and we will see ESLint there. Everything's going to be fine, and then it created app.js. So if we look at app.js, we can scroll down. Here we see the code for our calculator. And then if we scroll down a little bit more, we see the code for the main JS file. So it has bundled everything together so that now whenever we run the HTTP server with npm run HTTP, then we will be able to see the results in the browser. So let's head on over there. This is on port 8080. So let's go there and let's pull up the console. And there we have the result of 3. We've used Webpack to bundle our code together. We used ESLINT in conjunction with Webpack to ensure that we have good code and that it is bundled. And of course, all of this was available to us thanks to NPM. Webpack is an extremely useful tool. It allows us to bundle multiple modules and their dependencies into just a few static assets, so that whenever those are sent to the browser, it's done so with very few HTTP requests, which improves performance. But the big thing about using Webpack is that you can take advantage of a feature called hot module replacement. It allows us to exchange, add, or remove modules on the fly while the application is running without having to reload the page. And that is huge. It would be logical to want to take those benefits and apply them to the server as well, because just about every benefit that we get from the browser would be translatable to the server to some extent. So thankfully, using Webpack on the server is very straightforward. In fact, it's a lot like setting up Webpack for client-side development, but there's just a few things that are a little bit different. But first of all, let's look at this very simple application. Now, there is a source folder that contains public and server folders. These are the source files for our application. The public side is already set up to use Webpack. So you can see that there are 2 files, calculator and main. Main is the entry point that uses calculator. Those things are bundled together. And then the resulting file is app.js inside of public. So as far as the client side, Webpack is ready to go. We just need to set up Webpack for our server code. So we are going to start with our config file. Since we have both server and client, we can't use the same Webpack config file. We have to have a client config and then a server config, unless if we are building a universal application, which we are not doing here. Let's just take our existing config file and let's copy and paste it, because this gives us a great starting point for our server config. And I'm going to name this file webpack.server.config.js. Ideally, we would change the name of the other file to be webpack.client or browser or something similar, but we're going to leave that as is and just focus on the server stuff. Inside of our server config, we of course want to change the entry point. Our source code is inside of source and server, and the entry point is main, which is very simple. We're using Express, which has already been installed. We're referencing an about module, which is very simple as well. All it is sending as a response is some text that says about us. So this would be the about us page. And you can see that for the /about URL, that about module is going to be used. But we're also going to be using the static assets inside of public. So these are the 2 files that we want to bundle for our server. So inside of our server config, we're saying that the entry point is main.js inside of source server, and the output is not going to be public. We're going to just call that server as well. And let's go ahead and call the file name app.js. That goes in line with what we already have for the client. But we also want to set a target here. We want to say that our target is Node. And this config file is going to work, but it's going to give us a little bit more than what we would want. So let's go to our package.json file, and let's take our existing command for building the client, and we're going to use that as a basis for our build server command. So let's change the name from build client to build server. We will still run ESLINT, except our code is inside of source server. We will still save fix and cache. But when it comes to running Webpack, we want to specify our config file. So we'll say webpack.server.config.js. And so now let's go to the command line and let's say npm run build server. This is going to take a few seconds because this is not only going to bundle our code, but it's also going to bundle everything else inside of Node modules. And that's not necessarily something that we want to do. We want to take our code and bundle it. We don't want to bundle everything inside of Node modules. So instead, what we need to do inside of our config file is say that we want to ignore our Node modules. And thankfully, that is very easy to do because now we can use a module called Webpack Node Externals. Before this package existed, we had to manually go through, enumerate all of our modules, and then say, hey, ignore these modules. But with this module, it's called Webpack Node Externals. We don't have to do that anymore. So we're going to add this module to our project. Inside of our Webpack config file, we are going to require that. Let's call this node externals. This is going to give us a function that we will then use. So require Webpack node externals. And then there's another property that we're going to add to our exports, and it's simply called externals. This is an array. And now all we have to do here is say node externals, call that function, and it's going to ignore everything within node modules. So if we go back to the command line and we run our build server command, we are going to see that it is only pulling in our two files, main.js and about. There's another hidden file, but we don't have the ton of other files that were being pulled in before. So if we wanted to look at that, we can go to server at the root of our project in app.js. And if we scroll on down, we will see the code for the about page. There's that. And then here is the code that was in main.js. So let's add one more command so that we can run our application with just a simple command. And we'll just call this start. And start is going to call node, and then we specify server, and then app.js. Now we can go to the command line, and let's say npm start. That's going to run our command. We can see that it is now listening on port 5000. So let's go to the browser. Let's go to /about, and we see our About Us page. And if we go to the root of our application, we don't see anything here, but there is nothing inside of the index file except a reference to the JavaScript file, which writes something to the console, the value of 3. So when it comes to building your applications, you want to use Webpack not only for the client-side code, but also for your server-side code. The same benefits you get for using it for the client translates to the server as well. One of the challenges every developer faces is managing different environments because we have at least two, a development environment and a production environment. And we could have even more environments depending upon the process of moving an application from development to production. So there are several aspects to managing different environments. There is managing the hardware and the software and the operating systems. But as developers, we are always responsible for our application's configuration in our separate environments. And that's really where the challenge is, because ideally, we want to have a different configuration between all of our environments. We don't want any of our configuration information to be leaked and then be usable in some other environment, especially our production environment. The way that we used to tackle this problem is with configuration files. For example, we could have a file called .env, and in each one of our environments, this .env would contain the values necessary for our application to run in that environment. So if this is our development environment, we could have the information for our development environment. Let's say that our DB host would be our development server, and then the DB user would be the dev user, and so on and so forth. This worked, but there's a few issues. For one, we have to manage these files. And if we are deploying between different environments, we have to ensure not to overwrite the .env file or the configuration file in our other environments. So that's the first thing. The second thing is that if an attacker gained access to the file system, well, we already have problems if that's the case, but we have even more problems because then they might be able to access our configuration file, read the data there, and then they have even more access. So in today's applications, we tend to get away from the idea of using configuration files, and instead we use environment variables. With saying that, configuration files are extremely useful for a development environment because it allows us to easily manipulate our settings so that we can actually develop our application. So when it comes to developing your application and you're in your development environment, go ahead and use a configuration file. Just be sure to ignore that file with whatever source control you're using. So if you're using Git, make sure to add your configuration file to the Git ignore because you definitely don't want to be committing that file to the main repository. By default, Node is not going to read a .env file. So we can either do that manually or we can use a package to do that for us. And there's actually one called .env. So let's go ahead and install that. It's called .env, and we will save this dependency. And it's really easy to use. In fact, let's go over to some code and let's use it. So the entry point for this application is this main file. So the first thing we want to do is import .env from .env. And then we simply do this .env.load, and that's going to automatically read that .env file, and it's going to add everything in that to process.environment if it doesn't already exist there. And we will look at that here in a second. Let's just do this. Let's console.log process env and that db host. So we're going to look at the value of that. We can go ahead and just comment out everything else because we don't need that here. So all we are going to do is load our environment values from our .env file and read data from it. In the console, we will need to rebuild this. So we will say build server. That's going to run ESLINT. It's also going to build it with Webpack and then NPM start. And we should just see development server there in the console. And we do. Now, I mentioned that this is not going to overwrite any existing environment variables. That's a really great thing because if for some reason we forgot to not deploy this file to some of our other environments, the values inside of this file is not going to be used in those environments. As you are developing your application, yes, definitely use a configuration file. However, make sure it is ignored by your source control. Make sure you do not deploy it to your other environments because you still don't want that information leaking out. So let's look at a brief example of using an environment variable. Now, of course, this is going to differ based upon your operating system, and it could differ in a variety of different ways. On Windows, we could set an environment variable using the command line, but I'm going to use the graphical interface. We're going to set this to db host, and then this is going to be production db server. So something completely different than what we have for our development values. And in this case, I'm going to have to start up another command line so that we will have that value there. So this is inside of O'Reilly and Webpack example, and we'll just simply start our application. And here we will see the production server is being pulled in. So even though the .env file is still there, that .env package is respecting our environment variables. When it comes to working with different environments, use a configuration file for your development environment. Ignore that configuration file with your source control. I'm sorry to repeat myself, but this is very important. And then in your other environments, use those same settings, but as environment variables. JavaScript is a fantastic language, and it continues to get better with each new version. It's amazing how far this language has come, from its very simple beginnings to running full web and desktop applications. And now that we can use JavaScript to build these incredibly rich applications, it's important to follow the best practices so that your code performs well and so that it's easy to read and maintain. It's my hope that by watching these videos that you walk away with a better understanding of how you should write your code. But also don't take everything that I said as gospel, especially regarding syntax. As I mentioned several times, many of the quote-unquote best practices are subjective. They're based upon someone's opinion about how certain things should be done. I certainly injected some of my opinions, and even though that there are many developers that agree with me, that doesn't necessarily mean that you do. But there are certainly some things that you should do. Write modular code because that makes your code easier to write and maintain. Use the appropriate pattern for creating objects. We talked about a lot of different creational patterns, and some are better than others in certain circumstances. So use the appropriate pattern. Keep your JavaScript outside of your HTML. Don't embed it anywhere within your HTML. Keep it separate. But we also talked about having HTML in your JavaScript is now acceptable. So if you're using something like React, don't worry that much about it. But do separate your CSS from your JavaScript. You should update your CSS by manipulating CSS classes, not by manipulating individual style properties. Avoid excessive DOM changes. It's better to make a few large changes than many small changes. Lint your code with ESLINT. Bundle both your client and your server code with Webpack. And finally, use environment variables to store your Node application's configuration. Only use an actual config file during development, and be sure to ignore that file with your source control. If you follow these concepts, you will be well on your way to writing good, clean code. Thank you so much for watching this course.